Thank you very much. Let's all be seated. Namaste. NTPC welcomes everyone to the seminar on green hydrogen pilots in India. We extend our heartiest welcome to Honorable Minister of Power and New and Renewable Energy, Shri R.K. Singh Ji, Secretary MNRE, Shri Bhupinder Singh Bhalla Ji, Special Secretary and Financial Advisor to the MOP, Shri Ashish Upadhyay Ji, CMD NTPC Limited, Shri Gurdeep Singh Ji, CEO NTPC Green Energy Limited, Shri Mohit Bhargav Ji, honorable dignitaries and dear participants. It is an absolute honor for us to have Honorable Shri R.K. Singh Ji grace the occasion today as the chief guest in the seminar on green hydrogen pilots in India, which entails meaningful conversation and discussions on extremely pertinent topics related to the green hydrogen. I request CMD NTPC Limited to welcome Minister Sir with a bouquet. Thank you very much, sir, for taking out time and gracing the occasion. It really means a lot to us. NTPC Limited, as you all know, under the aegis of the Ministry of Power, is India's largest power generation utility. It has presence in the entire value chain of the power generation business and is committed to partner in the global energy transition. It is indeed a moment of pride and honor for us to host you in the seminar, which is on the sidelines of the G20 summit. The event would showcase different green hydrogen pilots being undertaken in India by public and private sector alike. These pilots play a pivotal role ushering in the development of green hydrogen economy in the country. India launched the National Green Hydrogen Mission in January 2023. The National Green Hydrogen Mission aims to provide a comprehensive action plan for establishing a green hydrogen ecosystem and catalyzing a systemic response to the opportunities and challenges of this sunrise sector. The discussion today during the day will help in assimilation of information and encourage sharing of achievements and challenges faced by the early movers. I now invite CEO NTPC GEL, Shri Mohit Bhargav, to welcome the August gathering.
Thank you and good morning. Most respected Honorable Union Minister for Power and New and Renewable Energy, Shri R.K. Singh Ji, Secretary MNRE, Shri Bhalla Ji, Special Secretary, Ministry of Power, Shri Ashish Upadhyay Ji, CMD NTPC. I also see in the audience Ajay Tiwari Ji, Additional Secretary, Mr. Ajay Yadav, Joint Secretary. I also see CMD Grid Controller, Mr. Narasimhan Ji. My directors on the board, first and foremost, welcome to this seminar. And apologies that we have not been able to provide enough seats. So we see this has actually generated a lot of response. So this room probably is actually kind of smaller than the number of people who want to come in. And the credit for all of this goes to our Honorable Minister because he has put hydrogen at such a high pedestal today that the moment one says hydrogen seminar, we have a lot of people coming to the room to listen to the Honorable Minister. So without further ado, this was an event which we have taken up under the aegis of Ministry of Power and MNRE. The idea is that while a lot of discussions are happening in line with the National Green Hydrogen Mission, which has been launched by you, there are a lot of pilots also happening, which we believe are very pivotal to taking actual commercial decisions going forward. So these are pilots, while NTPC is doing some NHPC, THDC, Assam Gas, we also have private companies like Acme, L&T, Hygenco. So all of these will be making the presentations today, and we are quite hopeful that going forward, these will be useful, not only in terms of making things better, making sense better, it will also help us in deciding how to take things forward when we move into the commercial phase. So once again, welcome all of you, and let's hope we have great deliberations and discussions during the day. Thank you so much.
Thank you very much, Mohit sir. Thank you for setting the context. I now request CMD NTPC Limited, to give the opening address. As you know, Mr. Gurdeep Singh is the CMD of NTPC, a 73 gigawatts, $16 billion company founded in 1975. So,
good morning. Honorable Minister, sir, Honorable Secretary, MNRE, Special Secretary of Ministry of Power, Sri Ashish Upadhyay ji, my colleague from our NTPC Green Energy, Mr. Bhargav, all invited guests. I can see and most of the people who had been having the keen interest in the hydrogen, presently who are in the ministry or in the corporations or maybe in the advisory role, from both sides, I can notice many people. As Mohit just was mentioning, I think when the name green hydrogen comes, I think there is an instant kind of willingness to come and listen and participate. And the credit whole goes to the Government of India and Honorable Minister that he has been just covering the various aspects, and the government has already brought in the hydrogen policy, which is paving the way for the future. I think there is no doubt that green hydrogen is going to be the fuel for future, and green hydrogen is going to be the real, I think, option rather than any hydrogen. I think this is what comes very clearly. I always start thinking that how the solar generation has really taken up in the country. I remember 2008-9 when we were in Gujarat, we were discussing about this solar plants, and in 2009-10 when the first 1 megawatt plant was inaugurated, I think that was a very, very big news. And after that, I think how the solar has really taken up. Probably hydrogen will have the similar kind of track. And these kind of seminars, when we are discussing, this is going to pave way how we can design our policies, how we can have the more investment into the technology, in the manufacturing, in the supply, and other usages, I think, which will be really giving a kind of impetus. And maybe I think in next 1 decade, the hydrogen will become the mainstream rather than only as a kind of in the future. And in that direction, what the ministry and the leadership of Honorable Minister has been taking pioneering steps. And from today's discussion, also many inputs will be coming, which will be really helpful. We as NTPC, we had realized this almost about 3 years back that hydrogen is going to be very important for the transition and for NTPC as a business opportunity. And we had been looking at some of the pilots, and the first pilot what we have already commissioned is in case of our township, where the from the floating solar, we are converting to green hydrogen, and that green hydrogen is injected in the PNG network, and that is being utilized in the township. So that was a the small step, but I think quite important on that. The another one I would just like to share with you is that what we are doing in case of Leh. Our bus is already there, the hydrogen bus, and this was again, as was desired by Honorable Minister about more than 2 years back, that we should be taking up the hydrogen buses. So that bus is going to be running on the hydrogen fuel. This is FCEV, and the hydrogen will be produced from the solar power in Leh itself. So we will be able to avoid this taking the whole imported, let's say, the fossil fuel which is coming, and then just in the refinery, then it's coming all the way up to the Himalayas. So I think this will again really give the kind of, as a pilot, this will prove to be a very useful. We believe that in next about a month or so, we should be in a position to make it kind of this pilot as a functional, and we can invite each and everyone. Incidentally, we lost some time because of the recent heavy rains and some of the roads getting broken during this on the way and going up to that. Otherwise, we would have commissioned this project by now. The another very ambitious pilot project what we are taking up is in the Vindhyachal, where this is 10 ton per day production of green methanol, which is already in the advanced stage of commissioning. We have already commissioned the carbon capture project, and we have the hydrogen, which is the renewable energy, and the hydrogen plant is also under construction. The methanol plant after hydrogen and CO2 is now also under construction. So once that is coming, we are trying our best that if we can do it by 31st of December, sir, and we will be very feel privileged if you will be able to spare time and then just inaugurate that once we are completing that. So that is going to be the another one, which is, and our request in that has been that this should be considered as a green methanol. I think there has been worldwide, there has been some kind of momentum which is taking place that it should be only from biomass or something and a non-fossil fuel-based carbon dioxide capture. I think this is not something which is probably genuine enough. So these kind of things, what the pilots, I think they will be really helpful in scaling up both sides in the size as well as numbers. I think this is good. And it is quite heartening that it's not only the public sectors which have started taking the pilot projects, but also private sector, in addition to the PSUs which are taking the pilot projects. And this is not only from the point of view that what can be done, but these pilot projects will also be helpful to understand the nitty-gritties and the standards, and how to standardize the products, what kind of input materials will be required, what kind of skill sets will be required. I think these pilot projects will be really basis for the kind of development of the total ecosystem in a long run. I think this is going to be very, very important. So someone can say that why we are having this discussion about the pilot projects, but I think the pilot projects are going to be the really, I think, the very, very important going forward. In addition, we are also discussing, like with the green, the shipping initiatives. We had been discussing whether the methanol can be utilized by them. We all know that green ammonia is very easy option. I think then everybody is looking at present, but I think green methanol is another one which can be really easily transportable and used. If you will just see outside, there is one startup which is taking up who have displayed his I think equipment here, that how the methanol can be converted into through the electrolyzer, through in the various electricity. So these things, and I'm not even talking about that this hard to abate sector, because that is what I think there will be much more focus on those things. But the points what we are discussing is what is required and what the common man will also be using. The another very forward-looking project what we have taken up is with the Indian Army in the area called Chushul, where we will be having our solar plant, and then we'll be having the hydrogen, and then again converting hydrogen through the electrolysis to power, so that they can avoid kerosene and the other fossil fuel. I think these all pilot projects will go in a long way, and sir, under your direction, and you had been always pushing us and motivating us to take up new and new projects under these things, and we are very eager to listen to you rather than me going forward. But sir, with your directions, we will be able to carry out further pilot projects if it is required, before it is becoming commercially viable and the private sector is jumping into this, like what is being seen in the renewable energy. Thank you, sir. Thanks for it.
Thank you so much, sir. Thank you for leading from the forefront, not just in the space of power generation, but also taking the green hydrogen project forward. I now request Shri Bhupinder Singh Bhallaji, Secretary MNRE, to give the keynote address. An IIM Bangalore alumnus and IS since 1990, he has a legacy.
Honorable Minister of Power and New and Renewable Energy, our Special Secretary Shri Upadhyay, Ministry of Power, our CMD NTPC, CEO NTPC Green Energy, my colleagues from MNRE and Ministry of Power, ladies and gentlemen, good morning everyone. First of all, I would like to extend my appreciation to NTPC for taking the lead in organizing this significant event, which brings together key stakeholders to discuss the pilot projects under the National Green Hydrogen Mission. NTPC's proactive involvement highlights its commitment to environmental sustainability, technological innovation, and the national progress. It is a commendable example demonstrating how public sector enterprises can play a vital role in driving forward transformative initiatives that benefit us all. As you are aware, the National Green Hydrogen Mission was launched earlier this year with a significant budget allocation of around 20,000 crore, spanning over 7 years, which is a visionary step towards energy independence and environmental responsibility. At its core, the mission aims to position India as a global hub for the production, utilization, and export of green hydrogen and its derivatives. It is a strategic move that promises to reduce our dependence on fossil fuels, combat climate change, and ensure energy security. However, the real stars of this mission are the pilot projects, which have been allocated 1,466 crore in funding and hold the key to innovation and experimentation. Out of this amount, rupees 456 crore is set aside for steel, rupees 495 crore for transport, rupees 115 crore for shipping, and rupees 400 crores in total for other projects. So we have a large budget for pilot projects as well, and that is why this event is so important today. These pilot projects are strategically designed to tackle sectors that have been traditionally reliant on fossil fuels, such as steel production, long-range heavy-duty mobility, energy storage, and shipping. By replacing fossil fuels with green hydrogen in these sectors, we not only reduce our carbon footprint, but also create new economic opportunities and jobs. What sets these pilot projects apart is their role as innovation laboratories. They allow us to test cutting-edge technologies, evaluate regulatory frameworks, and develop the necessary infrastructure. The data and insights gathered from these projects will be invaluable for us as we scale up and commercialize green hydrogen technologies. In this endeavor, we call upon industry leaders, researchers, and entrepreneurs to think beyond convention. These pilot projects are not mere steps. They are canvases for innovation and creativity. As we embark on this journey, we seek contribution from all stakeholders to shape the future of green hydrogen industry. By 2030, which is not too far out, the mission aims to increase India's green hydrogen production capacity to an impressive 5 million metric tons per annum, reducing our dependence on fossil fuel imports. In this endeavor, such projects have the potential to stimulate over rupees 8 lakh crore of investments and create more than 6 lakh jobs, providing a significant boost to our economy. Additionally, the green hydrogen produced is expected to avert nearly 50 million metric tons of CO2 emissions annually, underscoring our commitment to sustainability and climate action. Under the mission, these pilot projects encompass various areas, as I had mentioned. They promise to revolutionize these sectors and set new standards for sustainability and innovation. We have already requested that there are several ministries involved in this endeavor. We've already requested Ministry of Road Transport and Highway, Ministry of Steel, and Ministry of Port, Shipping and Waterways to work on these pilot projects so that we can start them at the ground level. I also just to wish you inform that the R&D roadmap under the mission is almost finalized and will be released shortly. The R&D roadmap also, the draft of course is there in the public domain. It details the various areas of research required to develop the green hydrogen ecosystem. We are also working on necessary regulations, codes and standards. We have sent the necessary first set of recommendations to agencies like BIS, PESO, OISD to adopt the relevant standards. You would also have noted that India has notified its green hydrogen standard for the purpose of the mission, which limits the CO2 emissions to less than or equal to 2 kg per kilogram of hydrogen. The National Green Hydrogen Mission's pilot projects represent a holistic approach to ushering in a green hydrogen revolution. They exemplify our commitment to a sustainable and prosperous future. So let us embrace these projects with enthusiasm, for they are not just experiments but blueprints for a cleaner, greener and more prosperous India. Thank you so much.
Thank you so much for your empowering words, sir. I take the opportunity to welcome CMD REC, Shri Vivek Devangan ji, and CMD NLC, Shri Prasanna Kumar ji, who are here with us. Thank you so much, sir, for joining. And well, now is the moment that we had all been waiting eagerly for, to hear it from the leader himself, who has not just been championing the cause, but also guides us, motivates us, and shows us the way forward. Ladies and gentlemen, Honorable Minister of Power has made significant contributions to the power sector in India, especially with respect to connecting Ladakh to the national grid, reducing the peak power deficiency, and Saubhagya scheme. Please, let's hear it for Honorable Minister, sir.
Thank you. Bhupender, the Secretary, Ministry of New and Renewable Energy. Ashish, my Special Secretary in the Ministry of Power. Gurdeep, the Chairman Mine Director, NTPC. Vivek, the Chairman Mine Director of REC. Ajay, the Additional Secretary, Ministry of Power. Ajay, Joint Secretary, Ministry of New and Renewable Energy. Mohit, the CEO of NTPC Green. Officers, ladies and gentlemen. There is a saying, it's called seize the moment. For India, this is the moment. For long, we have been importers of energy, and huge importers of energy, because we are a large country, and we are growing. If we don't do something about it, our import bills will multiply, because our energy needs will grow as our economy grows, and our economy is growing at 7%, 8%, and it will continue growing at that rate in the coming 2, 3, 4 decades. That's what's mind-boggling. You have this huge economy which will continue growing at 7% to 8% in the next 2, 3 decades. This is the fastest growing large economy in the world, and it will remain so for the next 3 decades. So can you imagine the requirements of energy? It's huge. My power demand has gone up by 21% in August, 21%. I mean, no other country has seen this. On a daily basis, my power demand is about 40 to 50,000 megawatts, more than the corresponding day last year. Now that's the scale of, that's how fast we are growing. Electricity is a clear indicator, just like human body's temperature, electricity is a clear indication of where the country is going, whether the country is growing or not. and it's growing, let me tell you that. 21% in August. In July, it increased by 9.78%, compared to the previous year. In 21-22, it increased by about 6.3% compared to previous year, which had grown by 6.7%. So it's accelerating. The growth is accelerating. And consumption of electricity I am citing as an indicator of that growth. Now, so we had to do something about this huge imports of energy. And this is the moment. I thought about this, and in fact, I had called experts from the IEA to give me a presentation on hydrogen. At that time, that expert had said that the moment for hydrogen has not yet come, but it arrived just about 2-3 years after he had said that. And we have the potential to be one of the biggest manufacturers of green hydrogen in the world, because we have set up a huge ecosystem of renewable energy, huge ecosystem. Our pace of capacity addition in renewable energy is huge. It's one of the fastest in the world. And because we have set up this huge ecosystem, and because of our natural advantages, our cost of making renewable energy is one of the lowest in the world. And because of that, our cost of producing green hydrogen will be one of the lowest in the world. Now, the world has realized it. It realized it very early, that India will emerge as a huge exporter. So, they are trying different tracks. The one track which has been tried, or which is being tried, is to talk about not only green hydrogen, but clean hydrogen. Now, when they say clean hydrogen, what they mean is hydrogen made from natural gas, which, if you make hydrogen from natural gas, you sort of liberate 11 kilograms of carbon dioxide for every kilogram of hydrogen. That's what it is. And, they were even allergic to the word green. Why? That showed them in a bad light. So, and they said that, let's not talk about green hydrogen, let's talk about clean hydrogen. I said, nothing doing. For me, green hydrogen is the sort of mantra. That's my object. And we have stuck to it. And by and large, other countries are also following. Europe has now by and large fallen in line, and they are moving away from so-called clean hydrogen to green hydrogen. And by and large, the world will follow this line, despite all these attempts. And there's also attempts at setting up barriers by various countries, trade barriers. We have to be cognizant of these things. We have to be aware of what is happening, and we have to contest it. Now, this, as I said, this is the moment because we have the potential to emerge as exporters of energy. From being a potential candidate for a huge importer of energy, we have now the potential to reverse it to become exporters of energy. And of course, there is the environment. We are not responsible for the mess environment is in today. Our contribution to the global CO2 load is just 4%, our population is 17%. But we believe in the environment. And therefore, our government believes in the environment, our Prime Minister believes in the environment. And that's why we have emerged as a leader in energy transition, because we've fulfilled our NDCs 9 years, 10 years in advance, both our NDCs. We've upped our ambition. And green hydrogen, when we sort of pivoted towards green hydrogen, our motivation was, of course, number one, to become energy independent, and number two, the environment. Now, in green hydrogen, a number of pilots are already going on. And people have, around the world, people have got off the blocks, and you have many pilots around the world for green steel. We have some pilots here as well. I believe ArcelorMittal is having a pilot. Some other companies are also having pilots in green steel. Pilots in heavy transportation, you've already heard, Gurdeep. We already have pilots in green transportation, heavy duty transportation. Because electric mobility is not viable for long distance heavy mobility. The battery size will be so big that it will not be worth it. So the hydrogen is the answer. Hydrogen or ammonia is the answer. You can refuel it faster, and it is lighter, so the long distance heavy mobility. Shipping. Now, shipping also, around the world, countries are making some ships ready. And these things will happen. shipping will go green. Just give it about 5 or 7 years, the world shipping will go green, maybe 10 years. So we have to be prepared for it. We have to emerge as a refueling destination for all the green ships. That's our ambition, because we can provide them green hydrogen or green ammonia at the cheapest rates, or green methanol, whatever fuel they sort of want. We can do it at the lowest cost. So we have to be prepared for it. We have to prepare bunkers at the shipyards. And we have to, again, also have pilots of our own. We provided for that in our mission, that we'll have pilots for green shipping of our own. So we are in talks with the Ministry of Shipping. We'll have a meeting with them to push it further. Similarly, and many of these actually, from pilots, one can say that one way is financing. I'll come to that later as to how we will run these pilots. I have some ideas running in my mind. Similarly, you look at storage, green hydrogen as storage. That is again something which is close to our heart, because we have found some lithium reserves, but the bulk of the lithium reserves have been tied up by one country. Our lithium reserves should look promising, but bringing it out, processing it, it will take time. Green hydrogen or green ammonia as storage for round-the-clock renewable energy. We'll come out with a pilot for that. These pilots, as has been said, or and there are some sectors where you don't need pilots. It's just a question of substitution. Now, these pilots are basically starting points at transforming the sector, moving away from fossil fuels. For example, let's take steel. We import the bulk of our requirements for coking coal. We had some coking coal, now we've run out of it. So we are importing the bulk of our requirements for coking coal. There is a simpler process, direct reduction, using hydrogen. So it will be advantageous for us if we go in for direct reduction using hydrogen and using green hydrogen. That's the direction to go. We are one of the biggest manufacturers of steel in the world. We aim to continue to be so. Only that we'll have to now transform our steel industry, and we'll have to push in that direction. It's benefit in the long run. It's beneficial for us. Similarly, as I said, for transportation, whether it is shipping or long-haul mobility, it will be beneficial for us. The methods of running the pilots, what I was thinking was that most of these are actually potentially already commercially viable. For example, my assessment is that if I have round-the-clock renewable energy using green hydrogen or green ammonia as storage, I don't think that the cost of that will come to more than 4 rupees 50 paise or maybe 5 rupees 50 paise. There are already companies which have developed turbines, which can use hydrogen or which can use ammonia for making electricity. And so these pilots are actually initial bids, and I believe that we can replicate this on a large scale, round-the-clock renewable energy. Now that will at one stroke free me from the problem of going in for large-scale imports of lithium-ion batteries till we have our own manufacturing capacity. We are setting up our own manufacturing capacity, but this will be a better option, because this will be entirely homegrown, and we can start off from the word go. And believe you me that is absolutely necessary. That is absolutely necessary, because my demand is expanding at such a rapid pace. I need capacities at a rapid pace. To set up a thermal power plant, it will take me about 7 years, 8 years for every plant of maybe 800 megawatts, whatever. And this we can do it in 2 years, 2.5 years flat. So the pace at which we are growing, this is the solution. Round-the-clock renewable energy using green hydrogen as storage. Similarly, I believe that the pilot for long distance heavy mobility can be structured in a way that we provide the refueling points. We provide, we have bids for refueling points. And we say that these routes are earmarked for heavy mobility using hydrogen. And we'll provide the, refueling points and maybe making hydrogen at all these refueling points in a dispersed manner. And by and large, I believe that if we give, the VGF for maybe the first round, the second round, from the third round onwards, or if from the second round onwards, no VGF will be required. That's my belief. The way the petroleum prices and diesel prices are going, my belief is that it will emerge as commercially viable. Now, if you want to make something successful, you have to make it commercially viable. And the commercial structuring is the key to any, the project. That's the key. Once you have structured it commercially, then it will run by itself. You will not have to give VGF again and again. You will not have to give subsidies again and again. So that's how I was thinking of structuring it. Similarly, I'll have discussions with Ministry of Shipping about how to structure this conversion of ships into green ships. Now, the Cochin Shipyard is already doing it. They're already doing it for foreign companies. They can do it for our Shipping Corporation of India. So again, we'll discuss as to how to structure it. The world is changing. And the difference this time is that we are the leaders in this change. We are at the vanguard of this change, not trailing behind the rest of the world. We are leading the world. The rest of the world can come after us. So that's what we are. We are a different country. Thank you. I wish you all the best.
Thank you so much, sir. We are full of gratitude. Every time we hear from you, we are filled with enthusiasm, vigor, and determination. Your motivation, guidance, and leadership has encouraged the entire power sector to take giant leaps. On behalf of everyone, each one of us, I request NTPC CMD to present a planter as a token of gratitude to Honorable Minister, sir. Thank you very much for doing the honor, sir. And here we take a short break. It's a short tea break for which all of you are invited to enjoy a cup of high tea, but be back very, very quickly because we'll continue with the discourse ahead. We have a series of discussions lined up. I thank Honorable Minister, sir, and each one of the dignitary on the dais. Extremely, extremely grateful to you, sir. Okay? Rule number 1. If you have your mobile phones with you, please keep it on silent mode. Please check your phone once because it's going to be an extremely important session and we do not want the speakers to get distracted at all. Kindly check your mobile phones, put it on silent mode. Rule number 2, let us be extremely respectful to the speaker. Could we all maintain a little silence and give the speaker the respect he or she deserves? And rule number 3, this is for the speakers though. So the speakers have a time limit of 10 minutes. We request you to keep to the time limit. There's somebody who will be operating a bell to keep with your time. And when it's about 2 minutes left to the presentation time, you'll hear a bell, which means you have another 2 minutes to wind up the presentation. Okay? So with this, I invite our very first speaker of the session. We have around 11 to 12 presentations ahead lined up, each not more than 10 to 15 minutes, and on very, very pertinent topics. The first topic is green hydrogen blending in PNG. Blending of GH2 with PNG, with gradually increasing the blending to 20%, aims to reduce carbon dioxide emissions while maintaining the same net heating content and import substitution. This is being tried out first by NTPC in Gujarat for domestic consumers for cooking and being attempted by Oil India at Assam. I now invite Mr. D. Lakshmanan, Senior Manager Hydrogen from NTPC, to present the case. He looks after green hydrogen engineering in NTPC and has expertise in green hydrogen domain with respect to mobility, hydrogen energy storage, and blending in PNG networks. Ladies and gentlemen, Mr. Lakshmanan.
Good morning to all, and today we are going to discuss a very important topic on green hydrogen. So that is hydrogen blending. So what NTPC we are doing at Kawas, green hydrogen blending project. The contents of my presentations follows, like the objectives and features of my project, and the project details, the basic brief, and how my system performance and what are the assessments and analysis we are carrying out in my project, and learnings, what we take away from the project. So for India, why green hydrogen blending is very important? There is because of two reasons. One is energy security, and which ensures a reliable long-term supply, and decarbonization, which will have a sustainable and eco-friendly fuel. So these are the very important two factors which hydrogen blending plays in a very important and pivot role in green energy sector. The main objective of this particular project is to showcase what is the technology validations in terms of design, execution, and operation of the pilot hydrogen blending project. And what are the safety requirements, regulations, standards which comes into the hydrogen blending project. And to understand what are the impacts of green hydrogen blending in the PNG networks, material, gas composition, those are the main objective of this particular pilot project. And last, what is the main understanding of the consumers, that is concerns and perceptions. So those kind of important parameters which we can take away from this particular pilot project. This is a brief details of my NTPC pilot project at NTPC Kawas township. So where we are having a GA network by GGL, and we are blending from 5 to 10%, 20% of green hydrogen blending, and we are having an in situ hydrogen generation from RE power, that is floating solar, and we'll be storing a hydrogen, and that stored hydrogen will be blended with the piped natural gas. In this particular project, we carried out safety studies to understand what kind of risk is involved, how my hydrogen disperse in case of any event, leakage or fire, or those kind of assessments we carried out rigorously, and the outcomes has been implemented into the system. And NTPC that is commissioned India's first green hydrogen blending project on 2nd January this year. This is a broad scheme where a part of a green hydrogen will come to my electrolyzer. I'm splitting the water into hydrogen and oxygen, and the hydrogen is stored, and parallelly I'm feeding to the blending skid and pumping into the PNG network. And these are some of the safety provisions which we have incorporated in the system, and some main features are like having active and monitor, PID controllers, H2 analyzer, which are very critical for this domestic hydrogen blending projects. And coming to the system performance, actually this particular hydrogen blending project is not like a normal blending project which we are doing in a PNG grid or CGD grid. This is basically like the consumption is not uniform. The flow of natural gas is not uniform. You have to keep on monitor, track the natural gas flow continuously. Since it's a domestic project, and the domestic gas consumption will vary very huge. You can see in the graph how huge variation is there. So your system should capable to detect those kind of variation and to inject the required amount of hydrogen, even at the low flow also. So that is a speciality of this kind of project, where you will be having a very minute control on the control valves, PID and PLC system, all those things. And coming to the very important concept or important for this particular project is that what are the different assessment we are doing in this pilot project. The first is this gas assessment. In gas assessment, we are carrying out two things. One is to understand what is the composition, and then what is the impact on the odorant. So you can see that chart where for the past 2 months, the data has been projected here. So we are having the data of the remaining months also, where we can able to ensure that there is a perfect homogeneity in the natural gas with hydrogen blending. So this we have ensured at different locations in order to get the exact data. And next is coming to the odorant. So odorant also, whenever we are dosing an hydrogen into the PNG network, whether the odorant level is coming down or there is any impact. So those things is also we NTPC is rigorously analyzed, and the results have been shown that there is no impact on odorant in case of 5% of dosing with hydrogen in the PNG network. Next assessment is on materials. So this is a very important, because everybody in India, even NTPC before starting into the project, we also had a very huge doubt how the material will be there because of the hydrogen exposure. So we conducted various studies in P pipeline and GI, rubber components and burner. And we conducted various studies, composition, tensile strength, macroscopic examinations, and corrosion mapping, that is thickness survey. So where we could able to find out there is no adverse effect on this hydrogen blending. And the right hand side you can able to see the microscopic view of the different studies in different materials, where you can able to see there is no distortion in the lattice-stick structure of the materials, and there is no discontinuity in the material properties also. So it directly gives some state points that this hydrogen blending at this particular 5% is not throwing any bad impact on the PNG network. And another important component of this particular pilot project is to understand the user concerns and their perceptions. This is very important. Without their consumers, you cannot do anything. So we, NTPC, carried out a training for all stakeholders, especially for the homemakers who are mainly responsible for this hydrogen blending system. Every 3 months, we developed a training material, checklist, safety procedures, all these informations. And we conducted a continuous consumer survey so that to understand what is there in their mind, how the systems is performance. So based upon that, corrective actions has been taken. These are some of the economics behind the hydrogen blending project. So this is a cost comparison just we have taken for this pilot project. Since this pilot project is a small capacity, up to 10% of hydrogen blending, when you are comparing with the LPG replacement with a blended PNG, so it is very much economical. But if it goes more than that, the cost will be little bit high. But if you are going with a commercial scale of big domestic or big network, this cost is also will be reduced. So hydrogen blending project, it will become a viable solution in future in India. And these are some figures on India import, how Indian imports can be reduced if you are considering hydrogen blending at 2%. Why there is a restriction on 2%? Because if you are considering a total CGD network, there is a restriction to have a 2% because of the CGD network. And there is an IS standard also which restricts up to 2% of hydrogen blending into the PNG network. And the main and final outcome of my particular project, what we learned from this particular pilot project, that is a fail-safe design, how my system can be designed without any issues. Starting from the commissioning till date, we could not observe any problem in the pilot projects. We never received any system design as well as operation kind of fault in the system. And next, we standardized a technical specification or anything for domestic to a big commercial projects. The main is that what are the checks should be involved in commissioning and operation of the system, and how to evaluate and performance of the system, and what are the impacts and assessment in the PNG network, and how to optimize the economics, how to give a better system in a safety and economical way, and what are the risk assessment and mitigations are involved in these particular projects. And these are my presentations on green hydrogen blending pilot projects. And thank you so much for all for listening, and thank you so much.
Thank you so much, Mr. Lakshmanan. Thank you. That was very insightful. We go ahead with the next presentation, which is on green hydrogen mobility. Now, as you know, this is being done by NTPC in Leh and Delhi, Oil India at Assam, and NHPC at Kargil. Generation of green hydrogen from solar power and dispensing at 350 bar into the fuel cell buses is done in order to make transport sector become zero CO2 and particulates emissions. So I have with me Mr. P. Rahul, Senior Manager NTPC, who will be talking on the topic. He has expertise in the domains of green hydrogen, green chemicals, and energy storage.
Thank you, ma'am. Good afternoon, all. My name is P. Rahul. I'm Senior Manager NTPC. So I'll be presenting about the green hydrogen mobility project being undertaken by NTPC. After the electrifying addresses by the honorable dignitaries here, we'll be presenting the pilot projects that we are undertaking and also the pilot projects of different organizations across the country here. So I'll just quickly start with what the mobility project of Leh, which is much talked about nowadays, is all about. It has a solar plant, dedicated solar plant. The solar plant of 1.7 megawatt capacity produces 80 kgs of hydrogen only during the sunshine hours, stores it at 500 bar, and then finally dispensing at 350 bar to 5 fuel cell buses. The project has key deliverables, which are many, but I would just list few. It has an altitude of 3,500 meter. So that's a very unique location that we have chosen to actually see how much of solar is generated at that much of level, and how the inverters are generating, converting from DC to AC, and what my actual generation in these Himalayan regions are, and then what optimal design I should adopt in terms of sizing with respect to the solar I have. So that ratio we will be finalizing, and then how to actually generate hydrogen only during daytime, which is a unique thing. Direct co-located plant generating hydrogen in situ, and then what should be my ramping and ramping up and ramping down. And then we are also having a fuel cell based CHP and then a battery system, so that during evening hours the system goes into standby and everything runs in order. So that's a special thing. And of course the fuel cell buses at those terrains, what are the speed torque characteristics, how much mileage you actually get, which we talk very theoretical nowadays, and what will be the public experience, and what are the approvals required ultimately for all these things. By doing all these things, we are getting ready for large scale up of such projects. Similar project we are doing at Delhi, where the capacity is 3 times, around 260 kgs per day, also 5 buses, but this time it will be intercity rather than intracity. So a very brief comparison that we have given, it's a plain region, Delhi, and then you have operation, say for same duration of 10 hours. Here you have a 500 kilometer range, and at Leh we are using a 200 kilometer range bus. There we are only using the sunshine parabolic curve, sunshine hours power generation from the solar power, and mileage we are assuming that 12 we'll get at both the locations. The only challenge at Leh is the extreme temperature. So this project has many firsts. It is India's first green hydrogen fueling station, and also the first at such a high altitude. It's the first commercial deployment of FCEVs. First bus we have already taken at that position, and the trials have started, and also in-situ generation of hydrogen. You can see the snowfall in the area where our fueling station actually is located. So you can see the temperature ranges as well. So you can see how challenging it is. Nonetheless, it's an important project for us to see. What are the special features? It has a super ECBC complex, and it is completely net zero. We won't be importing anything from the grid. We will be using the power generated, and according to the generation, using the EMS, we will be generating the hydrogen and then ultimately dispensing into the buses. To take care of the nighttime standby requirements, we have BESS, we have fuel cell, and the solar plant also has many firsts and uniqueness. There's special pile design because of the soil or the terrain that we have there, and we have a high watt peak module that we are using. Solar plant is almost at the fag end of its completion, fueling station is under completion, and buses we have taken to Leh for the trial. Safety provisions, you can see that we have taken utmost care and designed the system with all safety precautions. Standards, we are complying with all the standards that are there in ISO. Few standards are yet to be adopted by the BIS, but still we are following the ISO standards. Gas cylinder rules, all the piping ASTM standards, hydro testing, gas detection system where we'll be detecting any leakage that is there, temperature sensors, and then also we are having the fire sprinklers and water sprinklers and CO2 flooding system. And we are also doing different specifications that are required, and also as a proactive step, we are adopting from different standards across the world that we have. So this is the brief hydrogen station layout that it's the actual model of the station that we are going to have. You can see the extreme left, we have the super ECBC complex that we have. At the back side of the complex, you can see the electrolyzers, extreme to it, extreme right to it. You can see the compressors. Then extreme right at the top, you can see the storage area where there is 8 meter of clearance at the storage area. Here there is 8 meter of clearance that we have ensured. This is the electrolyzer. This is the DM plant, smaller one that you can see. This is the compressor shed that we have. And then hydrogen, the blue line shows the flow of hydrogen, and then hydrogen ultimately would come to the chiller and then the dispenser. So it's a complete station that we have. We have also planned the parking of the buses here. Buses can get filled up and then apply for the entire day. So this is, in very brief, we have shown what we are doing. Thank you for all your attention.
Thank you very, very much, Rahul. So this was Green Hydrogen Mobility. And ahead up in the series of presentation, we invite Shri Gopi Shankar from Ashok Leyland, Vice President, Advanced Engineering. The topic he's going to present on is FCEV and H2ICE vehicles. He's an automobile professional with over 25 years of experience and is instrumental in designing fuel cell engines for trucks and buses.
Yeah, thank you. Good morning, all. Thank you for this. Sorry. Okay, so I'll also do it quickly. So you know these trucks are of different applications. You know, some carry milk, some carry water, some carry, you know, trucks between the states, and there are trucks which carry other trucks. So the applications are very varied. Similarly, buses, there are intercity, intracity, city buses, there are much different varied buses. And all this has been running on diesel for so many years. Recently, we have come with the BS6, which was very recent, but now what we think going forward is we are in the decade of transition. What has been primarily diesel trucks, some amount of electric buses and a little bit of CNG is going to migrate. This is a decade of transition where we see a lot of hydrogen. And going forward, beyond 2030, we expect a huge amount of mobility to be run on hydrogen. So with this, let me go into the hydrogen. Today I'm going to focus only on the different pilot projects we are doing with some of the great partners we have. Of course, the green hydrogen is the clean energy fuel, and there are two ways of using hydrogen in mobility. One is as an internal combustion engine, and second is as a fuel cell. So as an internal combustion engine, you know this is you take the hydrogen into the engine and burn it, just like you do a diesel or you do a CNG gas, you burn it, it releases energy. In fact, hydrogen has 3 times more energy than diesel, so it generates power. The rest of the vehicle remains mechanical as it is. But there are many pros and cons of doing this. I would only like to touch the last 2 points is written there. One is the density. The density of hydrogen is very low, which means for a given space, very small amount of hydrogen can be there. And if you want to generate so much of power, you need to push in so much of hydrogen into the engine. So that's a challenge one. The second is the storage. Now we are talking about storage outside, as Rahul was also telling the 500 bar storage, but storage on the vehicle is again a challenge. You have to store, again, hydrogen being light, you have to pressurize it to 350 bar. That's a limit as per today's standard. And then a 350 bar on our current standard cylinder is about 8 kgs of hydrogen. That's what it can store. So there again, technology innovations are going forward. So these are 2 things which is happening. So we have built the vehicles. The whole vehicle will look like diesel. You just replace the diesel engine with the hydrogen engine and replace the diesel tank with a hydrogen tanks. So that's how the vehicle comes. So we have done a lot of testing inside, but more importantly on the partnership, we had developed in partnership with Reliance 4x2 and 6x2 long haulage heavy duty vehicles. So these are 19 tonner and 28 tonner vehicles. We have almost 23 vehicles built, and these vehicles are operating at Jamnagar at this point of time. These vehicles are under trials, multiple trials such as safety, application base, the TCO aspects, all are being under study here. Our Honorable Prime Minister had flagged off this vehicle in Bangalore at the India Energy Meet. So this is one set of pilots that is going on. We are not stopping with this. This is the first engine of 220. We are developing the next range of higher power engines as well. Because as I said you, the trucks are coming in multiple variants. So similarly, you need different horsepower engines as well. So we're building the 250 horsepower and even higher. And this was the vehicle we also presented at Auto Expo. This is a 250 horsepower, 41 tonner hydrogen ICE vehicle. So that's the other vehicle which is possible in hydrogen. This also is under testing. Now I'll quickly move to the hydrogen fuel cell. I think you might have seen the fuel cell which is being demoed outside. A fuel cell is typically a kind of a chemical reaction where hydrogen and oxygen reacts to form water, and in the process it generates electricity. So very simple experiment. And when this electricity comes out, the electricity is used as in the electric vehicle. You use the electricity to drive the motor and the vehicles. A typical fuel cell vehicle look like this. The front portion you have something called fuel cell here, which is kind of a chemical. You have the anode, cathode, and also the PEM layer where the electricity gets generated. And you have the hydrogen tank stacked up from where the hydrogen is poured into this. And then all the drivetrain down is a typical electrical vehicle. You have a motor, you have a battery, you drive it. Of course, here the biggest advantage is the battery size is extremely small. You can run with a 50 kilowatt hour or 70 kilowatt hour because the power is generated in the vehicle itself by the fuel cell. And here you have multiple options of fuel cells, battery and all. Now here, similarly, we have the options for the bus as well, where different layout is available on this as well. Here, coming to the major pilots we are doing here. First is the long haulage 35-tonner fuel cell pilot we are doing with Reliance. So this is a 100 kilowatt fuel cell with 250 kilowatt motor. It has 4 cylinders and it has with 33 kgs it can easily go around 400 kilometers of transportation, around 35 tons of payload. So this is one of the partnership we are doing. The second big partnership is the Adani's with Adani and Ashok Leyland. This is this is the world's first tip trailer. Fuel cell has never been applied on the mines. So Adani has requested, and we both are jointly developing this unique vehicle where the fuel cell will be operated on coal mines. It has its own challenge in terms of the dust there, typically dust that flies off the dry coal, and this is being done in the Rajgarh in near Orissa, and this fuel cell tip trailer is planned to run there. This is an important pilot, because once this pilot gets done, we have a understanding of the running on Indian operating condition in terms of temperature, humidity, the kind of dust, the kind of operations, the safety requirements. All of this gets validated, and then it can be parallelly, horizontally deployed in many other applications as well. This is a typical spec of this. You have a tractor trailer, 55 tonner, around 120 kilowatt fuel cell and 220 kilowatts motor. We will have around 25 kilograms of hydrogen in 3 cylinders, which will run around 250 to 300 kilometers over these mines. That's a key point. And the crown of all this was the NTPC. Where along with NTPC, we had this partnership to drive the fuel cell bus at the world's highest motorable road. This is very significant again, because at 11,000 feet you have very low amount of oxygen and the temperature is freezingly cold. In these conditions, again, this is a pilot. We are running these buses there, as Mr. Rahul also indicated, lot of trials, understanding the performance, understanding the TCO of these operations, so that net is it profitable to the customer. All this is being done. This is a typical specification of the bus. It's a typical 9-meter bus, around 35-seater, and it has a 80 kilowatts fuel cell with 120 kilowatts motor power, around 3 cylinders, and primarily for intra-city applications. In addition to this, we are also doing a Delhi project which will have a intercity applications kind of for a 500 kilometers. So this is my last slide, but some of the core areas that need to be focused in this hydrogen is what I would like to indicate here. The first and foremost is the efficiency management. You can carry only so much of hydrogen, and if you want to get the range, you need to manage efficiency. So you need to calibrate based on the applications. You need to develop some regeneration technologies, some energy storage devices as well. The second most important is the safety management. There's a thought that hydrogen is dangerous. Not really so. Hydrogen is very safe gas. You need to handle it properly, just like we handle an LPG or a CNG. So, but we have all the hydrogen safety systems, the ADAS, and the different levels 1 and 2. Analytics and simulation is very important, because you need to have the TCO running positively to the customer, so we run with the right efficiency, right range and all. And finally, advanced materials for lightweighting. Of course, the battery and the fuel cells adds to the weight, so we need to find the cost also a little higher. The fuel cell cost is higher, the tanks cost are higher, so we need to find ways of cost reduction with various supplier partners and all. So with this, I'll come to conclusion of this last slide from Ashok Leyland. We are pushing into the renewable energy, particularly hydrogen, in a very big way, and with the help of our partners like NTPC, Reliance and Adani, we hope we'll do a lot more pilots. And with these pilots, we gain a lot more information, and the vehicles will be, made for India, applicable for Indian operations. Thank you.
Thank you very, very much, sir. And this is a good time to express our gratitude to the MNRE, the mobility projects that we have been talking about, the green hydrogen mobility and the FCEV and H2 ICE vehicles have been generously supported with grants by MNRE. So thank you very much for it. We now move ahead to green shipping initiatives. Instead of using petroleum-based oil, fuel cells fueled by green methanol are being tried to supply motive power to steamers. This is same as green mobility, the difference being methanol as fuel to fuel cells and waterways. I invite from the Cochin shipyard, Mr. Deepu Surendran, who has more than 25 years of experience. He is General Manager, Strategic and Advanced Initiatives, and is handling the hydrogen fuel cell powered by ferry vessel pilot project.
Good morning to all. I am from Cochin Shipyard. Cochin Shipyard is public sector undertaking under Ministry of Port, Shipping and Waterways. For shipping also, there is a transition of fuels happening, and as per International Maritime Organization's target, GHG emission target is fixed as 0 by 2050. Under this, various green shipping initiatives are happening. I am taking you through various projects undertaken and various pilot projects which are under concept stages for this green shipping. The first project is, it is a battery hybrid vessel, ferry vessel, that is for Kochi Water Metro. This is for the multimodal integrated transportation system. It is part of that, and various transportation systems like metro rail, road transport and water metro is connected with the islanders to the mainland. And these vessels are having 100 passenger capacity with fully air-conditioned passenger space, and these vessels are operated with battery, and diesel generator is also on board the vessel, but that generator is used only for emergency operations and high-speed applications. The battery used for these vessels are LTO batteries, and these vessels are first phase, it is 23 vessels, and 9 vessels are already delivered, and its interior is exactly looking same as that of metro rail coach. And these vessels are operational now. It is inaugurated by our Honorable Prime Minister on 25th April this year. And next phase also there are vessels, and a total 75 vessel fleet will be there. Once that is completed, that will be the world's largest single electric fleets of vessels. And these vessels can be replicated in other river lanes and lake cities. This is another vessel which is autonomous zero emission ferries, which is with a fully battery operated vessels, which we have constructed and delivered 2 vessels to ASCO Maritime Norway. These vessels are for crossing Norway and Oslo fjords of Norway, And these vessels are designed for autonomous operations, and these are under trials now. And these vessels are delivered last year, June. Now it is in Norway, it is operating. Once this is completely operationalized, this is an autonomous, fully autonomous vessels without any crew on board. And these vessels are with batteries. This is one of the ambitious and prestigious project as a pilot project which we have undertaken. This is a hydrogen fuel cell vessel. This vessel is a 50 passenger ferry project, which is exactly similar to the Kochi Water Metro. The platform is similar, but there is no diesel on board. It is having PEM fuel cell, 50 kilowatt PEM fuel cell plus lithium iron phosphate battery. And these vessels are constructing with, it is a fully indigenous homegrown technology. We are partnering with a company called KPIT. They are marinizing the fuel cell and powertrain for this vessel. And Indian Register of Shipping as formation of rules and regulations for these types of vessels, and also certifying agencies agency for the components and the vessel. And 75% of this vessel is cost is funded by Ministry of Port, Shipping and Waterways. And these vessels are advanced stages of construction and will be completed by this September. That is our target. This fuel cell and other vessel automation and power system, everything is integrated and testing is happening in KPIT premises in Pune now. And this is one of the future vessels for the zero emission for urban mobility applications. This project, once it is proven, this can be under National Hydrogen Mission, this can be pilot projects can be deployed in different parts of the country. This is another electric catamaran ferry. This is, we have received order for 8 numbers from Inland Waterways Authority of India. And these vessels will be operating in 4 locations, Varanasi, Ayodhya, Madurai and Guwahati. And this is another opportunity of green ships for urban mobility solution. This is another project which we are constructing now. This is for an Cyprus owner. We got order for 2 vessels. This is wind farm service vessels, CSOV. These vessels are used for servicing and of wind farm, offshore wind farms. And this is high-end technology vessels, and these vessels are having methanol dual fuel engines, and ultimately this will be operating with methanol. And this methanol, main part is these methanol engines are manufactured in India by MAN in their Aurangabad plant, and construction is already started last week, and our Honorable Minister of State for Port, Shipping, Waterways and Tourism, Sripat Naik ji has already done that steel cutting ceremony. This is another vessel, zero emission feeder container vessel, that is also for Norway. This is 2 vessels. This is powered by hydrogen fuel cell. It is 1200 kilowatt hydrogen fuel cell. These vessels are one of its first kind, and it is coming, and it is supported by Norway's green shipping funding called Innova. There are different decarbonization initiatives we have, concepts we are ready to roll out. One is a RoRo vessel. It is a hybrid electric vessel. Similar vessel with the diesel powered vessel is already running in Kochi for crossing the channel for transportation of people and vehicle. This concept vehicle is vessel is with LNG plus battery and solar. This can be used for crossing rivers, for carrying people and vehicles. This is another project or concept we have developed. This is hybrid tax, battery hybrid tax, and this is for greening the port operations. These are coming under green tech transition program that is announced by the Ministry of Port, Shipping and Waterways. The government is trying to transition of all the fossil fuel trucks to ultimately to green hydrogen and its derivatives. It is in a phased manner, and first phase it will be with the battery hybrid vessels. And these are another two concept projects which we are having, and this is also a proposal under pilot project under National Green Hydrogen Mission. One is 8,000 DWT coastal bulk carrier, and the other one is coastal tug. These vessels will be with methanol or ammonia engines, and we are expected to complete this by 2027 as pilot projects. Another initiative is this is by Ministry of Port, Shipping and Waterways. This is a National Center of Excellence in Green Ports and Shipping. This was established by Ministry in partnership with TERI, and this center is located in TERI's Gurugram campus. And this is promoting by 4 organizations under Ministry of Port, Shipping and Waterways, and we are one among them. And the ultimate aim of this center is to make all ports greener and to establish India as a green hydrogen hub and to establish India as a green ship and shipbuilding center. Thank you.
Thank you very, very much, sir. Thank you for your insights, and we'll take a moment here to, as a token of gratitude, I'd request Mohit Bhargav ji to kindly present a small appreciation from our side to you, sir, for sparing time and for sharing your insights with us. This is Mr. Deepu Surendran, General Manager, Strategic and Advanced Initiatives from the Cochin Shipyard. Also, we'll take a moment here to felicitate Mr. Gopi Shankar, Vice President Advanced Engineering from Ashok Leyland. Sir, if you could also come up and join us on the stage. It means a lot that you have spared your valuable time to be with us in the seminar today. Thank you. Thank you very, very much. And now to go ahead with the presentations, next up, I invite Mr. Chaitanya from H2E. Yes, Mr. Chaitanya is from H2E. He's a mechanical engineer by profession. He has over 7 years of experience. And he looks after the business development of H2E and is involved in 2 ongoing green hydrogen-based microgrid projects.
Thank you.
All yours.
So he'll be talking to you on green hydrogen-based microgrid and other initiatives, which is about generation and storing of green hydrogen from renewable energy and converting back to electrical energy.
Yeah, thank you so much for my introduction. Hello everyone, I'm from H2E Power Systems. H2E Power Systems basically dealing with the electrolyzers manufacturing as well as the fuel cells. We do a
You can carry on.
So we do a manufacturing of electrolyzers and fuel cells. At the same time, we do a complete turnkey solutions on hydrogen value chain. In my presentation, I'll show what kind of projects we already did it in India and installed. So my topic today is for the green hydrogen-based microgrids. Yeah, thank you. So basically, so this is the conventional and distributed power generation in the India at the moment. So you are just producing the electricity from the thermal plant, and you will just transfer it to the different level. But we are just having a different module for the distributions where you can generate the power at the site and you can utilize that power to your utilizations. So this is called a microgrid where you can use the power for different applications. So I'll just go through the microgrids, what exactly microgrid is. So we divided the microgrids in 2 different forms, where one is in the small networks where remote electricity is not available. we are using the microgrids. So it's like in the solar hours, we can generate the electricity for maybe for 5 to 6 hours, is depending on solar hours. And after that, you can store that hydrogen, and you can utilize that hydrogen for the different applications, like for the applications to given the power to the guest houses, or maybe for running different machineries. It's depend on that. So it is the smaller networks. We already done this kind of a pilot projects with DRDO, with L&T Gujarat, where this fuel cell will be directly used for the EV charging stations. So they have developed a complete renewable plant where solar, then there is a wind, and after that we just given them a fuel cell based systems. So these are the different bigger, or I can say a microgrid connected board generators, where we can use a bigger plant of electrolyzers. We can have a more distributed chains in the societies, or where bigger margins are there. These are some, we already did some in India's demonstrator projects, for pilot demonstrator projects. First is Charge to Go. I'll just explain the Charge to Go. So this is the Charge to Go concept we developed with Indian Oil, where we use solid oxide fuel cells instead of PEM fuel cells. So we are using CNG as an input. So any hydrocarbons you can just give as an input, and you can produce electricity and heat at the same time. So we are using electricity for their EV charging stations, and heat will be utilized for the adsorption process, for the chilling, or maybe for their different laundry uses. So this is the unique setup we developed with Indian Oil. So this is a 4 kilowatt system. There is a two variant we developed. One is with NG base, with natural gas we are using, and second with diesel reformer. If you just have a diesel, you just need to give input of diesel. From the reforming process, you can produce electricity. So it is kind of a remote application we are using. This is will be installed in IOCL's one of the retail outlet, where EV charging stations will be used. So this is the POC stage. We already do a pilot in the IOCL campus in Faridabad. So it is with a PESO that there are some rules and regulations we are going to take. So maybe in next 2-3 months it will be in their retail warehouse. And second, with the Jorhat, India's first green hydrogen project, we did it in Jorhat with the help of Oil India, where Oil India have a 500 kilowatt of solar. So we utilize that solar and produce green hydrogen. So green hydrogen through AEM process, AEM technology called anion exchange membrane. We are producing around 10 kg of hydrogen per day in 6 to 8 hours. Solars. Then after that, we are just storing that 20 kg of hydrogen. We are compressing that hydrogen. We are utilizing that hydrogen in a different ways. We are using this for the blending with the natural gas, and we are giving it to the home consumption as well as the fuel cells. So we made a smaller modules with the fuel cell generations as well. And the second applications we use in Assam, in Jorhat, is for the buses. We already developed a hydrogen buses with the help of Oil India. So we already launched that bus in Bangalore, only in front of Modi ji. So we are using that bus. This bus is running in Kaziranga in Assam. It is in the trial versions. So it's look like that. So this is the second projects we are working. We face so many challenges that because we are working with a newest technology called anion exchange membrane. So these are the second, and so this is one of the microgrid projects we developed in IIT Madras. So we just gave them a complete microgrid solution to their green lab. So there is a green hydrogen. We given them electrolyzers of 2.4 kilowatt. And after that, they have a fuel cell of 3 kilowatt, which will be directly utilized for their green lab. So they want to run their complete system with hydrogen operated power. So we utilize that one. So it will be commissioned in next 15 days. It is already installed. And these are some microgrid projects we already done it in India. So one of the microgrid projects, we done it with NTPC Netra. So we were the part of a project with Spirari Energy, where the electrolyzers can be take part from the Spirari, and we are giving a 40 kilowatt PEM fuel cell based system. The power will be directly utilized to the guest houses to the NTPC Netra. So they want a 25 kilowatt net output of fuel cell, where 16 hours a day they want to run their fuel cells. So these are, we already done that installations in NTPC Netra. I already mentioned about L&T Gujarat. This is one of the different aspects of microgrid systems we already developed and we already installed in 600 homes in Germany. So this is the solid oxide fuel cell system. We have a model of 1.5 kilowatt, where you just need to give an input of any hydrocarbons. You will produce electricity. It's around 1.5 kilowatt, and the heat is around 2 kilowatt. So this heat in the Europe will be used for the space heating, but in India we use it through the adsorption process. It's for the chilling. So we already done 2 pilot projects, one with DRDO and one in Pune by ourselves in our lab, and still it's in the process. And this is one of the pilot we already done. It's in agriculture field. This is a 10-feet container where we installed fuel cell of 200 watt, which is running off LPG. So this complete system involved solar of 300 watt. Then there is a battery, there is a fuel cell. This will be used for the remote electricity given to the pump sets to the agriculture industry. So we have a small setup of up to 5 kilowatt, these things. We already done some pilots in Maharashtra, in the specific Maharashtra regions where this can be done it or not, because in solar hours they can produce they are having the electricity, but after that they don't have anything. So that's why this is kind of a power monitor, remote monitoring systems we develop for this specifically for the farmers. These are one of the pilot projects. It's a demonstrated pilot project for the Leh Ladakh, what we are going to work on. This is also remote applications that where electrolyzers, fuel cells, and other applications will be there. Yes, Rahul sir has rightly said that Ladakh conditions are difficult, but we already made an engineering what kind of winterization need to be done on the fuel cells to be sustained in the Ladakh region. So this is also the another industry application. This is not this is the industrial applications which will be used as a power backup for the data centers. So this is the 60 kilowatt solid oxide fuel cell systems where it will be used for the power backup for the data centers. We are doing one of the demonstration with one of the IT company in Pune, where electricity will be directly utilized for 60 kilowatt. And the heat will be used for chilling process. So they will directly going to the ACs, directly for the air conditions. And this is also one of the microgrid, and this is the most ambitious project of our CEO, Mr. Siddharth Mayur, who is founding this company. So this is specifically for the agriculture and rural industry, where I already explained you regarding the BJ Urja. This says it contains a fuel cell of 200 watt. So we are going to increase that fuel cell by 15 kilowatt to 20 kilowatt. So where this will be the power backup to the farmers. Thank you. Yeah. So this is only the brief about company. The company is founded by Mr. Siddharth Mayur, and which is strategically invested by Mr. Adar Poonawalla as well. So these are only the green initiatives we took. We do complete systems in the hydrogen generation as well as the applications in the hydrogen value chain. I'm really sorry I take so much of time. Thank you. That was only one thing I just want to say. So we are going to have a electrolyzers manufacturing plant in India in next 2 months. So the plant will be installed in next 2 months in Pune. So the first year it would be 100 megawatt, then it could be 300. So the 100 megawatt would be 80 megawatt would be the alkaline and 20 would be the SOE. And then we will go for the next step for the PEM and AEM. So the installations and everything is done. So the first batch will be starting next 2 months. Yeah. That's it. Thank you.
Thank you so much, Mr. Chaitanya. We really didn't want to hard press all of you, but we have a lot of speakers with us with a lot of very pertinent topics. So that's why I request Mohit sir once again to kindly come up and felicitate Mr. Chaitanya. If you could stay here for a while, we would like to present a token of appreciation from our side. Thank you for being with us and for presenting your case. Thank you so much, sir. Thank you for doing the honor, sir. Next up, let's talk about the green ammonia plant. As you already know, the green ammonia plant is made using green hydrogen when combined with nitrogen isolated from air. It is thought to help achieve a net zero, energy security, and import substitution. I would like to invite Shri Sandeep Kashyap, CEO, Hydrogen Business from ACME Bikaner. Mr. Sandeep is leading the ACME group in both solar and GH2 business for past 7 years and has developed India's first green ammonia plant at Bikaner, Rajasthan. Thank you so much, sir.
Thank you. How do I? Okay. So good afternoon to you all, and I'd like to thank NTPC for giving us the opportunity, for inviting us over here and presenting our green ammonia initiatives. Before going into the real initiative which we'll be covering today, we at ACME actually started our journey in the hydrogen space way back in 2006-2007 when we were doing telecom passive infrastructure. And that was the time we deployed almost 5 megawatt of hydrogen-based fuel cells in the country for the telecom sites. In 2008, the Lehman Brothers happened and the whole business model collapsed because the gas price shot up, and accordingly, at that time when we were buying hydrogen from chloroalkali plants, the price shot up and the whole business model collapsed. And that was the time we decided that we will only enter into this business once we will have a handle on the cost of hydrogen and nothing beyond that, before that. In the year 2017, we achieved a historic 2 rupees 44 paisa tariff for solar, which is equivalent to $10 per million BTU of gas. And that was the time we decided that now we can compete in this industry and we should start working on green hydrogen. And that's how we started working on our first project in Bikaner, which is a fully integrated industrial scale pilot for green hydrogen and green ammonia. We started construction in the year 2019, and 2021 we commissioned the project. The reason of coming out with the pilot was we wanted to go in for green hydrogen, green ammonia in a bigger way. Unfortunately, globally there was no reference, neither to the off-takers nor to the lenders. There was no reference of any such plant, and therefore, everybody used to ask so many questions that how it will work, where it is working, how it will trade, at what price it will trade, how do you make sure that you are making enough money. And therefore we decided that we should set up our first green ammonia and hydrogen plant to showcase to the world that yes, the technology works, we understand the technology, we can produce at a competitive price, and we can also showcase it to the off-takers globally. Now this is a plant which is having a 5 megawatt of solar plant integrated for generation of green hydrogen, a 2.5 megawatt of electrolyzer, and a 5 metric ton per day of green ammonia synthesis loop. It's been almost 2 years now. We have been producing green ammonia and supplying green molecules to the industry, and at a price of grey ammonia today, successfully. These are the components of this plant. We have, as I mentioned, we have 2.5 megawatt of electrolyzer. It is an alkaline type electrolyzer. The fundamental philosophy of production of green ammonia is we run this plant for generation of green hydrogen during the solar hours. And we generate that much of hydrogen during the day, which is good enough for generating green ammonia for 24 hours. Which means when there is no solar power, we run green ammonia plant on a 24/7 cycle and still produce green ammonia, because ammonia as a synthesis cycle cannot be stopped. Right? For that, we also provide additional energy to the grid, and we get that energy back under the banking arrangement from the grid during the night time. So this is a little more about the plant, how we have been running it, the same which I have explained to you just now. This is the block diagram of the plant, where on the left you could see the solar power, then the electrolyzer for generation of green hydrogen. We have the PSA unit and the cooling towers, and then we have the syngas compressors. We store the syngas as well as we produce green ammonia during the daytime, and we use the same syngas to produce green ammonia during the night time with bank power with the grid. And we have been supplying this ammonia, as I said, for the last almost 1.5 years' time to the industry. The specifications of the green ammonia which we produce is more than 99% pure, consistently, which we have tried and tested over and over again in various cycles of production. And then this ammonia is being transported. We have a couple of trading companies who have approached us in the last 1.5 years' time, and they have been feeding this material to various industries like fertilizers, steel industry, refrigerant, pharmaceutical, fermentation, and effluent control. These are the industries currently we are feeding with this. Typically, the transportation is for a 15 metric ton kind of facility. I'll just take you through a small video of the plant.
Welcome to the world's first green hydrogen and green ammonia plant. The plant is located in Bikaner in Rajasthan, India. Here, renewable power generated from solar PV plants is used to produce green hydrogen. The nitrogen is captured from atmosphere. Green hydrogen is produced by splitting purified water molecules into oxygen and hydrogen without using fossil fuels, using an electrolyzer. This technique is very clean and produces more than 99.999% pure hydrogen gas. The air available in the atmosphere is pressurized through the air compressor and being buffered by the filter and air dryer. This process produces 99.5% nitrogen. The green hydrogen and nitrogen are mixed and preheated up to 200 degrees Celsius. The product stream then enters into ammonia synthesis converter. Then it's further heated to 360 degrees Celsius. The final product is ammonia. The produced liquid green ammonia is stored in the pressurized vessel, which can be transported to anywhere in the world. By using world-class technology, the process is 100% emissionless. Acme, leading through innovation.
Thank you so much.
Thank you so much, sir. Thank you very, very much. So that was Acme, and that was a brilliant, brilliant presentation. Thank you for taking us and transporting us to your plant as well. Thank you. Yes, we'll go ahead with the session, sir, and then we'll have you back again for a while when our head is here. Sure. Yeah. Okay, so let's delve a little deeper into microgrid and mobility. Let's see what NHPC has been doing. I invite Mr. Krishnan Kumar, General Manager, RE and GH Division in NHPC. He has an experience of 22 plus years in the field of hydropower. He's heading RE and GH2 Division since 2021. And he'd be talking to us about how NHPC has been faring in microgrid and mobility.
All the best, sir.
सभी को मेरा नमस्कार. माई सेल्फ कृष्ण कुमार, जनरल मैनेजर फ्रॉम NHPC लिमिटेड. आज मैं NHPC जो ग्रीन हाइड्रोजन की फील्ड में काम कर रहा है उसके बारे में कुछ बताने के लिए आया हूँ. इस जो प्रेजेंटेशन मेरी इसके 2 पार्ट्स हैं. पहले मैं थोड़ा सा NHPC के बारे में ब्रीफ दूंगा. उसके बाद जो हमारे हाइड्रोजन के जो प्लांट्स हैं उसके बारे में आई विल स्पीक समथिंग. जैसे अभी हम लोग जो बात कर रहे थे तो मेरे साथी थे, वो पूछे थे कि सर NHPC और NTPC के बीच में क्या रिलेशनशिप है, बिकॉज बोथ नेम्स आर वेरी सिमिलर. तो मैं उनको बता रहा था कि बोथ कंपनीज वर इनकॉर्पोरेटेड 1975. NTPC was given the portfolio of thermal energy and NHPC was given the portfolio of hydro energy. Later on, अब गवर्नमेंट की जो पॉलिसी है, बोथ कंपनी जो है डाइवर्सिफाइड. NTPC हाइड्रो में भी है और RE में भी है, और NHPC अपना जो RE का फील्ड है उसमें कंटिन्यू कर रही है, क्योंकि हाइड्रो इज क्लीन सोर्स ऑफ एनर्जी, और हम लोग अब RE के अंदर विंड, सोलर और ग्रीन हाइड्रोजन के फील्ड में थोड़ा काम कर रहे हैं. बट स्टिल बिकॉज हाइड्रो इज ए रिलायबल एंड क्लीन सोर्स ऑफ एनर्जी, आवर कोर रिमेन्स हाइड्रो पावर. एंड RE के अंदर मतलब जो विंड और सोलर है उसके अंदर वी आर टेकिंग स्टेप्स वेरी कॉशियसली, बिकॉज like the projects we have done, they are not have been very profitable, so we are taking steps very cautiously in those fields. So NHPC was incorporated in 1975, and nowadays it's 74,000 I mean इसकी asset value है इसकी. Sir, we are having 24 power plants, in which 2 are from RE sectors and rest 22 are from hydro sectors. Our installed capacity is around 7,000 megawatt total as on date. In addition, we are constructing hydro projects of around 9,000 megawatt, and we are having presence in 15 states, 2 union territories, and we are having strong contract management systems, financials. So we want to capitalize on these abilities and want to make some capacity additions in the field of RE sectors and the upcoming sector of green hydrogen. Now about RE portfolio, as on date, we are having 100 megawatt our own capacity, 320 megawatt as intermediate procurer, and our 1,000 megawatt projects are under construction stage, which we have won through CPSU scheme. Other than that, we are planning 300 megawatt in Rangali, Odisha. It's floating solar plants. And it's other is 200 megawatt Gujarat. It's the ground-mounted solar project, and 50 megawatt floating solar Kerala. And in Rajasthan, our 1,680 megawatts projects of as intermediate procurer are under construction stage. The projects are getting delayed because of some GIB issues, but hopefully we are moving ahead on those projects. And our subsidiary BSCL, it has been assigned our RE portfolio of Uttar Pradesh. It's 26 megawatt capacity is commissioned out of 65 megawatt Kalpi project. Rest 39 is held up because of some issues in module sourcings because of BCD. Hopefully it will be resolved and project will move ahead and fully commissioned. Other than that, our subsidiary is taking solar parks of Jalon, Mirzapur, and Madhoghat. They are shall be coming up soon. And our subsidiary NHDC, Narmada Hydroelectric Power Corporation, it has been assigned the task of Madhya Pradesh. It's 88 megawatt in our own reservoir, Omkareshwar under construction, and 8 megawatt ground-mounted project is also under construction phase. Now coming to our core area, it's green hydrogen pilot projects of NHPC Limited. Sir, ma'am, we are taking total as on date 3 pilot projects in the field of green hydrogen, and these now I'll go on then. Our first project, it's microgrid. It's fuel cell based microgrid. It's located in Nimmo-Vajgu power stations. Here we are seeing our dam site, and besides the dam sites, there was an area which we have used for installation of solar plants and green hydro plants. Here you are seeing our reservoir. Along the reservoir, we are having an empty land. There we are installing our solar plant. Besides that, there is our hydrogen plant is near to our colony, and it will feed energy. I mean, it's intended to provide round-the-clock power to our guest house. And its main components are ground-mounted 325 kilowatt is solar PV plant, electrolyzers. These are pressurized alkaline type, having a capacity of 20 nm³ per hour for ensuring 14 kg per day level output. Fuel cell, we have chosen PEM fuel cell based because for RE energy, it's supposed to be the best one. Its capacity is 25 kilowatt plus auxiliary consumption. Sir, this is the brief single line diagram of our project. Our project you are seeing here. This is we have shown our guest house, and in the box we are having our existing scheme. Like the guest house is getting power from our plant only. It's Nimba Bazoo power station through an 11 kV line. Thereafter, we are having transformer, and we are having a bus. And for backup power supply, our guest house is having DG sets. We have planned to extend this bus and give power from our this microgrid. That's the hydrogen fuel cell, which will cover later on. Sir, this is a basic flow diagram of our Leh project. Here you see first we are having a solar array which will produce power. Solar plants produce power in form of DC power. Thereafter, inverters will convert into AC form, and our solar PV plant will produce excess power. In daytime, it will meet all the supply of our guest house, and the remaining energy we shall use for our hydrogen station. And by hydrogen station, we shall produce hydrogen and in daytime, and we'll store it so that we can use it in night time for giving our guest house round-the-clock power. So actually, this cursor is not visible here, but you can say solar array, thereafter inverters, AC load, hydrogen production, thereafter this fuel cell system and inverters. Here you can say AC load. First we have shown this daytime requirement, and in the last one is our nighttime requirement through hydrogen fuel cell. These are some site photographs. As on date, we have completed all our site investigation works. Geotechnical investigation was earth resistivity test. This is photo of our module inspections at OEM works. Like my colleague has already told, the site is very challenging, and here, the challenges we are facing right now, and how we are trying to mitigate them, we have covered them. Okay, I will try to cover it. Like extreme cold weather, the site remains isolated for the rest of India for approximately 4 to 5 months. High oxygen consumptions and rating of various equipment. For all these, we have taken some mitigation measures. And like some important, interesting techno-commercial aspects. Here, for providing round-the-clock power, our LSO is around ₹117 per kilowatt hour, and it's because of the cycle efficiency in the range of 17%, and the project is having high capex cost because of remoteness. It is also having small size. Our cost of hydrogen is coming around 2,000. You can say 2,500 per kg. CF is 31%. This is our mobility project in Chutak. It's in Kargil. Here we want to run 2 buses. This is our site, and this is our powerhouse, dam site. This is our layout. Solar PV plant 500 capacity, then hydrogen generation, compression, hydrogen storage, and dispensing at 350 power. It's a SLD. Thereafter, some other interesting aspects. We are having around 40 kg hydrogen per day. And again, you are seeing the cost of hydrogen production is around 2,650 per kg. And our electricity consumption per kg of hydrogen is coming around 84 units per kg. The project is under advanced stage of procurement, and its order for the project is scheduled to place in current month, this month only. Next one is our Chamera 3 power stations. Here also we are having a mobility station of one bus. The techno-commercial aspects of the project, layout of the project is quite similar to our Kargil project. Okay, just 1 minute. Just to sum up, I will say, like a journey of a miles begins with a one step. So NHPC is taking its initial steps in the field of green hydrogen. And with these projects, we have begun our journey. Hopefully, we will make useful contribution in this journey. Thank you. Thank you all.
Thank you very much, Krishan Kumar, sir. Thank you. Sir, could you please stay up on stage, and I'll request CONGEL to kindly come up and felicitate Mr. Kishan Kumar from NHPC with a token of appreciation from our side. Thank you very much, sir. Sir, if you could stay back a little, I'd request Mr. Sandeep Kashyap. Sir, if you could kindly come up on stage, and here's a small token of appreciation from our side. Thanks for being a part of this session. Thank you so much. Next up, let's talk about green methanol and green ethanol. Green methanol, the low carbon fuel that can be made from either biomass gasification or renewable electricity and captured carbon dioxide from coal-fired boilers. It eventually helps in curbing import of the same from the Middle East. Green ethanol, the syngas, green hydrogen and CO are a feed to the bioreactor and are produced to make green ethanol through biological processes. I request Dr. Swapnil from NTPC AGM Netra to help us understand the topic.
Thank you.
इसमें नाम होगा नहीं है ग्रीन मेथनॉल ग्रीन ये वाला ग्रीन फ्यूल वाला हाँ ये सर ऑल द बेस्ट
Thank you. Okay. Good afternoon. So it is a CO2 derived green liquids. Conventionally, whenever we do ethanol and methanol, there is a syngas. And in the syngas, there is CO2, CO, and H2. In flue gas, there is only plenty of CO2. So for the CO, we can tweak the catalyst and make a methanol. We can convert CO2 into CO by water gas shift reaction, which is used in ethanol. And we can use some waste. And from that, we can gasify it and use it. For a hydrogen, we are using a lot of water. So if water is in the scarcity, we can use some wastewater and use it for this one. So for these two topics, Samina and Prabhakar will talk. I will talk about this green ethanol. Whenever we go for the power production, we can see here that power is going to increase. Moreover, our renewable power is also going to increase. But the smaller point is the flue gas is also going to increase. So important thing is that we have to reduce the CO2 from the flue gas, and it is only possible if you will reduce the CO2 and utilize it. So if we have to capture the carbon, it is for the pre-combustion, post-combustion, and oxy-combustion. In the CO2 capture for the power plant is a post-combustion. So in the post-combustion, the CO2 is a lean. It is around, say, 11 to 15%. Temperature is around 100 to 120 to 30 degrees Celsius. And for that, of course, with some particulate matter and SOx, which will be done by FGD, this can be done in commercially at this moment by the amine processes. So the reaction here is by the chemist option. For the monoethanol amyl, the reaction is given. When the absorption happens, it is exothermic. And when we do the desorption, it is an endothermic with a higher temperature. So for this higher temperature, we have to give some energy. So if we use a primary amine, the absorption is very fast. But whatever the compound happens is also stable. So whenever we want to desorb, this desorption requires heat. So if we go for the tertiary amines, in that the absorption is slow, but the energy requirement is less. So these, if we have to combine both, then there should be a blend of these two, and this is modified amines which are used in our process for the CO2 absorption. So this is the main crux of the CO2 absorption. The flue gas will come. Of course, it is sanitized. All the SOx and NOx has been removed first. Particulate matter is removed. It is gone to the absorber column. From that, it will go for the rich liquid, which will go to the stripper column, and we will separate the CO2. The CO2 is a very stable compound. Whenever we go for the CO2, the heat, which is heat of reaction, which is minus around 400 kilojoules per mole. So we have to give this energy. If we see in the carbon, it is +4 of oxidative state. If we want some chemicals or fuels, we have to reduce it by the 2 units. So we have to give a lot of energy. This energy can be by the electrons, means electricity, or electrochemical. It can be photochemical, or with a thermal, with some reducing agent like hydrogen or some methane or something like that. Or we can go for the mild conditions with a polymetric materials, and which comes into the construction one. The lot of carbonates come. For this, we will require a lot of raw material wherever we will do this for the plant. So for this time, we are going for the ethanol, methanol, which is the fuel. And why it is so? As such, if we see the entire scenario, we can see here that there is a urea, which can be a very good product, or many fuels are there, which is liquid as well as gas. It is methane there, or it can be chemical. The chemical structurally is little bit more complicated. And whenever there is a complicated one, to construct it, it requires a lot of good chemistry and lot of good selectivity. Moreover, if we go for the simple compounds, from there we can go for the chemicals. So it is always better to go for the simple compound, which is methanol, ethanol, which is a fuel. Moreover, the fuel consumption is 15 times more than the chemicals. So it is always better to go for the more consumables, which is fuel. So this is the plant. First we have to capture the CO2, then we have to electrolyze and give the hydrogen, then we have to compress it, say around 60 bar. From the 60 bar it will go to the reactor. Say per pass conversion will be around 12 to 15%. So if we will keep it in the loop, our entire conversion will be around 95 to 99. We will get the crude methanol. After the crude methanol, it will go to the 2 distillation columns which are here shown. And from this, we will get the methanol, which is of the fuel grade. So in this, our CO2 capture is completed. We have erected and we have commissioned also. Hydrogen generation plant is in the erection. It's in advanced erection stage. This methanol plant is in detail engineering is almost completed, and the procurement will start very soon. This plant of the 10 TPD will be in the Vindhyachal NTPC. The second concept is with ethanol. In the ethanol, we are going with a biocatalyst. Biocatalyst is some kind of algae here, and from the algae, in the liquid phase, we will get some ethanol. But here we will require CO, and this CO will go with reverse water gas shift reaction, and from that we will get whatever the required input for the reactor. Of course, the hydrogen will be from the electrolysis. Then it will go to the distillation block, and from the distillation block we will get 4G ethanol. So if we have to see here,
The CO2 block is a 25 TPD, hydrogen is 3 TPD, and we will go it. Then the reverse water gas shift reaction, so required amount of CO will be there, and we can generate 10 TPD of fuel grade ethanol. So here it is, and now we will go for green hydrogen based plasma gasification by Samina.
Good afternoon, everyone. When we talk about green hydrogen, we know that the most common process used to produce hydrogen is the electrolysis process. But there are many challenges associated with the hydrogen, with the electrolysis process for the hydrogen production. As we know, the electrolysis process for the hydrogen production using electrolysis process consumes lot of energy, around 55 kilowatt hour per hour of energy is consumed to produce 1 kg of hydrogen. Also, if we go with the electrolysis process, the efficiency of the process is modest, around 73 to 75%. If it is alkaline based, and if we are using PEM, then efficiency goes to 74 to 77%. And the raw material that we are using for the production, for the generation of hydrogen using electrolysis is the water. So basically, we need very high purity water, which is DM water. So to produce 1 kg of hydrogen, we need 10 kgs of DM water. And if we go for the raw water, around 13 to 14 kgs of water is required to produce 1 kg of hydrogen. So if we use the raw water for the hydrogen production, again we need pre-treatment process depending upon the complexity of the raw water. Let's say if we are producing hydrogen using STP, sewage wastewater, then lot of pre-treatment methods are required, and which there also we have to invest a lot. Okay. Also, in the process of electrolysis, we face many challenges in the electrolyzer itself. Like if the membrane fails, then reverse reaction can also happen. Electrolysis is basically the splitting of water. So reverse reaction can also happen, and this hydrogen and oxygen can combine, and again we may have water. So these are the key hazards of the electrolyzer operation. So what can be the alternative of this process? So here I will talk about the plasma gasification process for the production of hydrogen using MSW waste or RDF. As we know, solid waste management is a biggest challenge worldwide. If I talk about in India, around 63 million tons of solid waste is being generated. And out of this, only 12 million tons of solid waste is being treated. And the most common methodologies used to treat solid waste are incineration or composting or biogas generation. So if we go with the incineration process, again there is a production of pollutants, and which degrades the air quality. So here I'll talk about the plasma gasification. So in plasma gasification, we are using RDF. So what is the motivation behind this plasma gasification technology? Basically, it is based on the oxygen. Oxidant here we are using is the oxygen, so it is basically oxygasification. So as we are not using air as an oxidant, so there will not be nitrogen in the syngas. Syngas is basically composition of CO, CO2 and hydrogen. So using plasma enhanced based gasification process, the expected syngas composition of CO, CO2 and hydrogen is around, CO will be around 34%, CO2 will be 20% and hydrogen will be of 34%, which is of very high quality. So here you can see that the molar ratio of hydrogen and CO is approximately 1. So if we want to produce methanol and ethanol using this syngas composition, we can easily do that, because generally the molar ratio requirement for the ethanol production is 1 for hydrogen to CO. Also, as we are not going to use reverse water gas shift reaction process in this process, Also, we are not going to use hydrogen electrolyzer, so it will be of low capex. This process will be of low capex, and also as electrolyzer is not being used, so 70 to 80% power consumption will be reduced and will have low OPEX as well. Also, we are using RDF as a raw material for the hydrogen generation here, and we know that in a hydrogen the sulfur component composition of sulfur is very less, so there will be a very less chance of generation of SOx, NOx. So the syngas we will obtain using this process will be very clean. So this is the novel route for the green hydrogen production using RDF by means of gasification process, as we are not going to use any kind of electrolyzer here. So what are the advantages of the plasma gasification? As the gasification process, it is very flexible. With the raw material, we can use any kind of waste, any kind of biomass, sludge for the production of hydrogen. Also, the process efficiency is greater than 99%, and raw materials are easily available. We know solid waste management is the biggest problem, so we can easily get the solid waste, RDF or MSW. Also, as we are using plasma here, so there will be a very little chance of tar and char generation in the process, and there will be very low carbon dioxide emission. And also, we have estimated the capital cost and operational cost for this process is comparatively less. So this is the configuration and building block which we are proposing for this process. So here basically we have 7 blocks. In block 1 we will have feed preparation, which will be our RDF. Then block 2 will be of plasma gasification. Block 3 will be syngas conditioning, basically syngas cleaning using plasma torch. Block 4 will be of syngas storage and compression, and then we have to separate out, we have to recover the hydrogen from this syngas composition. So we will have block 5 for the hydrogen separation unit, and further we can use this hydrogen for the electricity generation or for the other purposes. So idea is like, if we'll go with this process, RDF to hydrogen production, the total electricity requirement is 808 kilowatt, and the net energy we will get out of this process will be 478 kilowatt. So extra we have to provide 330 kilowatt of electricity. This 330 kilowatt of electricity will be providing from our solar based plant, which has been located in Netra NTPC itself. So the power consumption here per kg of hydrogen is around 9.62, which is very less, comparatively very less as the electrolysis process, where the power consumption is around 55 kilowatt hour, and the RDF consumption per kg of hydrogen is 30.37 kg. This is the schematic of the syngas production using RDF using plasma gasification process. So in the first block we will have the feed preparation unit, then we will have gasifier unit where we have plasma torch for the syngas cleaning. Then the evaporative cooler is there for the rapid cooling of the syngas, so that the hazardous compound, which is well known as a dioxin, which will not be formed. Then we have fabric filter, bag filters to remove the particulate matters. Then further, we will compress this syngas, and we will subject this syngas to the membrane separation unit to recover the hydrogen. After membrane separation unit, we have PSA unit to get hydrogen of very high purity, around 99.9%. So here the input of RDF is around 25 TPD, 25 tons per day of RDF will be using to produce 823 kg of hydrogen per, sorry. So if we'll go with this process, so the cost of the hydrogen production per kg will be around 166 rupees per kg. So the next project will be explained by Prabhakar.
Good afternoon, everyone. I'll take it through the topic, because already she has explained that there is a strong demand for water for hydrogen generation. And now we are at NTPC Netra, we have demonstrated few technologies that where hydrogen can be produced from low-grade waters. And I'll take it through the projects very briefly. The first one what we are seeing here is the electrolysis reversal technique. And in this, the wastewater which is collected in our campus, that is treated with the EDR technology, and this will be feeding to the electrolyzer, that is of 2 kWh per meter cube of power consumption. We can generate hydrogen required. And one of the advantages of the EDR technology is the higher membrane life compared to the normal RO membrane, and it requires very low pre-treatment, and this will be integrated with the 150 kg per day green hydrogen electrolyzer that is being under installation at NTPC Netra. And the second one is just a flue gas based seawater desalination project. This is already established in NTPC Simhadri. This is a 120 ton per day, and this process it uses waste heat from the flue gas, and through multi-effect distillation process we are making distilled water, and we are using this for further hydrogen generation. And the third one is, this is a non-thermal forward osmosis process. In this wastewater we are recovering, and we are producing DM water out of this by NTF4 technique, and this is also a very less energy intensive technique, and this will be integrated with another one hydrogen generation plant that will be installed at NTPC Moda. And this one is based on solar thermal desalination water technique, and this is also based on the multi-effect distillation technique, and this water, it will be taken for a hydrogen generation plant, and it will be installed at NTCL Vallur. So, thank you.
Thank you. Thank you very much to the entire team of Netra. Thank you, Dr. Swapnil, Samina, and Mr. Prabhakaran. I know there's so much to talk in so little a time, but you will get immense opportunity during the lunch break to interact with each other and take the discussions forward. You can do it up there. Going up ahead, let's talk about making of DRI steel with green hydrogen. DRI production process involves reacting the hydrogen directly with iron ore instead of using coke as a reducing element. It eventually lowers greenhouse gas emissions. To make the presentations, I invite Mr. Paramjeet Singh, Additional Industrial Advisor, and Mr. Bharat Thummar, Joint General Manager, AMNS.
Good afternoon, everyone. Since morning we are listening about that hydrogen production, and we are the industry where we have to use the green hydrogen to reduce the emission. The steel sector, iron and steel sector, is highly energy intensive, and because of the higher energy intensity, the emissions are very high because of the targets are very high. As it is told by Honorable Minister in the morning, that sector is one of the stakeholder where we have to use the green hydrogen. After getting the, you can say, communication from the MNRE in the end of the May 2023, Ministry has started already interacting with the industry, and with having the 2 meetings with the industry. We have seen that there is a high potential for the use of green hydrogen or the hydrogen in the steel sector. The areas what we have seen that where the hydrogen can be used is one is the blast furnace, and another area where the hydrogen can be used, the DRI, where the world is also working on. The hydrogen, we interacted with the industry, we found that there is a limited potential for the use of green hydrogen right now in the blast furnace. The main area where we can use high amount of hydrogen, either in the existing process or the new development of new process where we can use the 100% hydrogen. We received 2 or 3, you can say, proposals, and one of the proposal which I think which has a higher potential, that will be presented by Mr. Bharat. So I will not take much of the time on because of my speech. I will request Mr. Bharat to make the presentation of this. Thank you very much.
Yeah, good afternoon all. Just brief about MNS India. It's actually integrated steel plant being operated at Hazira, Gujarat, having almost present capacity of around 8.6 MTPA. And we do have a DRI modules. So we do have presently around 6 operating modules with an annual capacity of around 6.8 MTPA. These are natural gas based DRI modules. With for module 1 and module 2, we can see it's a cold DRI where the product is actually almost around 50-degree temperature. And module 2, 3, 4, 5 is a hot discharge plant where the discharge from the shaft furnace is at around 650-degree temperature. So coming back to the DRI process, we can see is a closed circuit where we normally use natural gas as one of the reactant for converting CO and hydrogen for the reduction purpose. So the shaft furnace where the reaction takes place, and in a one pass, only a 25% of CO and hydrogen used, and rest is unreacted. So two-third part of the gas is recycled back, and natural gas is added to generate CO and hydrogen. The reformer is almost similar to the plant that fertilizer plant do have. Only the difference is here we do have a stoichiometric reformer, whereas fertilizer plant or a refinery will have a steam reformer. So difference is actually only operating temperature and H2 by CO ratio. So we are maintaining H2 by CO ratio in the range of 1.5 to 1.6. Here also we have modified our process. This is applicable to our bigger modules, module 5 and 6, where we can see the 1/3 portion that is going to the fuel. Instead of that, we have utilized that gas and processing that gas and pass through a CO2 removal system. We do have a VPSS system where we remove the CO2, and whatever the product gas from the CO2 removal system is fed back to the process circuit. So that much CO and hydrogen, whatever added to the circuit, is not required. And that much amount of natural gas is not required to generate the CO and hydrogen. Instead of that one, whatever the byproduct gas, because steel plant normally generates a lot of byproduct gas. So here we are utilizing Corex gas as a fuel for the reformer and preventing or reducing the natural gas. So presently module 5 and 6 mega module having capacity of almost around 1.6 to 1.7 MTPA. We are replacing 35% of the natural gas with this Corex gas and 65% natural gas. These are actually the reactions that takes place within the shaft furnace. We can see that 1 mole of 3 mole of Fe2O3 required almost 3 mole of CO and hydrogen to get Fe. It's either CO or either hydrogen. So presently we are, this is a reforming reactions where we are generating CO and hydrogen. So in short, our process is actually very flexible, as we have already modified module 5 and 6 to accommodate usage of the waste gas or other byproduct gas that can be utilized for the DRI process. That demonstrate that we can presently utilize 30% of the hydrogen as and when required. Within a short, only a few pipings is required. So if hydrogen is available today, we can very well utilize and replace 30% of the total natural gas with the help of hydrogen. So that flexibility we do have. And also we are presently working to make our plant how to operate with 100% hydrogen. So what are the modifications that required in the present plant to make the utilization of 100% instead of natural gas. That still seems to be somewhat tough because finally still requires some amount of carbon. So we are targeting almost around 80 to 90% replacement of natural gas with the help of hydrogen. So this is actually the requirement. Presently, we are planning to utilize whenever the green hydrogen is available. So 30% directly we can utilize without any modification. And still we are working with a small pilot plant that can actually give a better idea what modifications that is required in the present configuration so that we can make necessary changes in the existing process, or whether we have to do some smaller plant that can consume 90% hydrogen. Yeah, thank you.
Thank you very, very much, sir. Thank you for your erudite presentation. I request Mohit, sir, to kindly felicitate the speakers on our behalf. I also request Mr. Paramjeet Singh to join us up here on stage. This is a small token of gratitude from our side, sir. Thank you so much to both of you. Thank you, Mr. Paramjeet, and thank you, Mr. Bharat.
Thanks for coming at such a short notice.
Thank you. Well, going up ahead, the topic that we often talk about, it's the order of the day. Microgrid initiatives, and let's seek inputs from THDC. The team members from THDC, Mr. Praveen Saxena, General Manager BD, and Mr. Pradeep Tripathi, Manager BD, if you could kindly come up on stage and help us understand hydrogen-based microgrid initiatives in your organization.
Welcome, sir. All the best.
Namaskar. Good afternoon, everyone. On behalf of THDC, I am here to give a brief description of our green hydrogen pilot project being developed at our corporate office, Rishikesh. Actually, we are having 1 megawatt rooftop solar plant at our corporate office, Rishikesh, covering almost all roof of our office buildings. That plant is already installed, commissioned, and generating energy. And we will utilize that solar power for our green hydrogen pilot project. But before going into the details of the pilot project, I would like to say a few words about our organization. The THDC India Limited was established in the year of 1988 with the sole objective of developing 2,400 megawatt hydropower complex at Tehri, which includes 1,000 megawatt of pump storage plant. And after commissioning of 1,000 megawatt Tehri hydropower plant in the year of 2006, and commissioning of Koteshwar hydroelectric plant in the year of 2011, THDCIL has diversified its business into renewable energy, including solar, wind, and we are also developing now a thermal power plant of 2 into 660 megawatt at Khurja. Now THDC has a portfolio of 10 projects in hydro, thermal, wind, and solar with a total capacity of 4,516 megawatt, and out of this 1,587 megawatt capacity projects are under operation. And we are also developing ultra mega renewable energy power parks in the state of Uttar Pradesh through our JV partner UPNEDA, And we are also developing 10,000 megawatt capacity solar parks in the state of Rajasthan with our JV partner RRECL, that is the Rajasthan Renewable Energy Corporation Limited. Now the green hydrogen pilot project, with a view to contribute from our side to achieve the target set in the National Green Hydrogen Mission, 5 MMT per annum. We are developing this pilot project at our Rishikesh corporate office. So what is green hydrogen? Green hydrogen mainly produced by two types, by water electrolysis or by reforming biogas in a steam reformer. And we have opted the process of water electrolysis for our pilot project. This is the pictorial diagram. These are the objectives of our pilot project. We want to demonstrate the technology involved in producing and storing the green hydrogen, generating electricity using green hydrogen through fuel cell, and thus demonstrating the potential of green hydrogen for energy storage system. What we have planned that after commissioning of my pilot project, it will produce a green hydrogen of 50 kg per day by operating the water electrolyzer during solar hours, about 9 to 10 hours. And the electrical energy required, as I said, it will be sourced from the rooftop solar plant, which is already commissioned and connected to the grid. Green hydrogen produced during the daytime will be stored in the hydrogen tank at a pressure of 30 bars, and we are using two tanks for storing the hydrogen. And during the night hours, the stored hydrogen will be supplied to 70 kilowatt capacity of fuel cell to generate the electricity. And this electricity we will be utilizing to illuminate our office premises as well as entire residential area of TSDC set up in Rishikesh. This is a process flow diagram. As I already said, the upper line we can see the rooftop solar plant is already installed and commissioned. This is connected to the grid. And as of now, we are sourcing the power from the grid for our consumption. The bottom loop, this is the additional we are implementing as our pilot project. We will draw electricity from the grid, bring it down to a level of 415. Then we will converting the AC power into DC, and we will supply the power to electrolyzer. The DM water, the raw water will be passed to the DM plant, and after sufficient dosing of electrolyte KOH, that will be fed into the electrolyzer, where oxygen and hydrogen gas will be produced. We will release the hydrogen in the atmosphere, and the oxygen in the atmosphere, and the hydrogen gas will pass to the purification system. From electrolyzer, we will be getting the hydrogen of purity of 98 to 99%, and after passing through the purification system, it will be purified to a level of 99.999%. And this purified hydrogen will be stored in the hydrogen storage tank. This process will take place during daytime, and during night hours, we will supply the stored hydrogen to the fuel cell, and it will generate electricity, and that we will be utilized for our illumination purpose. There are so many components of this system, and I request my colleague, Mr. Tripathi, to explain.
Good afternoon, all. These are some components, major components of our green hydrogen pilot project. The first one is rooftop solar power plant. As sir explained in process flow diagram, there is a installed and commissioned solar power plant of capacity 1 megawatt at our TSDC IL office complex. Then second one is transformer. We are sourcing electricity from 11 kV grid. Then it convert to 415 by a 600 kVA transformer. Then it is rectifier converting AC to DC. The next component is DM water feed system. The raw water from overhead tank from TSDCIL will be fed into the DM water feed system, and the demineralized water will be fed into the water electrolyzer, where
the next in the next component, we are using alkaline electrolyzer system for electrolysis of water and producing the hydrogen. In this particular alkaline electrolyzer, the water electrolysis process will be there, and the hydrogen, the water molecule will be split into hydrogen and oxygen. The next one is gas separation skid. From the electrolyzer, there is a mixture of oxygen and hydrogen. In the gas separation skid, the hydrogen and oxygen will be separated, and the separated hydrogen will be fed through the next system by a hydrogen purification skid. The generated hydrogen will contain the traces of oxygen and moisture. In hydrogen purification system, absorption, heating and cooling will be there, and from this process we can achieve the purity level of 99.99% from 98 to 99. The produced hydrogen after purification, we will use 2 number tanks of hydrogen storage having capacity of 12 m³ each. The 99.99% pure hydrogen will be stored in the 2 number tanks. The whole process, behind this, the whole process will take place in the day hours, 10 hours of duration. After that, in the night hours, we will use proton exchange membrane fuel cell of 70 kilowatt and feed this particular produced green hydrogen into this system. And by the process of fuel cell, we will generate 70 kilowatt 840 kWh equivalent energy to illuminate our office complex. This is the skid system comprising of electrolyzer, gas separator and purification skid. The bottommost part is electrolyzer, the coil type structure, and the above structure is gas separation skid. The right side is purification system. This is some real-time photographs of our pilot project. The pilot project is in implementation stage. The next is agency involved. Messrs. Advit Infratech is involved in this particular project as an implementing agency. TSDC is funding this project by its own sources. The estimated cost of the project is 9.74 crore, as we can see, with 3-year comprehensive operation and maintenance. Project status, the progress of this project is very much in line with the schedule, and hopefully it will be commissioned by October 2023. These are some outcome and comparative table for calculating the data. Just as in the process flow diagram, we have already explained that we are going to generate 50 kg of green hydrogen in 10-hour duration. The basic concept behind it is that we are taking 2760 kWh of solar energy, equivalent energy from grid or from a 415 volt level. The basic concept behind this is we are taking, like in earlier presentation also, they are saying that 1 kg of hydrogen requires 55 to 56 kWh of energy. If you calculate this particular 50 kg and compare with 2760, it is very obvious. The next one is 70 kilowatt fuel cell for 12 hours. We are assuming that 1 kg of green hydrogen contains 33.33 unit of energy, and considering the fuel cell output from fuel cell efficiency is 45 to 50%. And the next point is the cost of green hydrogen. Our estimated cost of green hydrogen is rupees 318 per kg, or we can say like $3.83 per kg. Considering the input cost is rupees 3 per kWh. As we all know, like solar cost is almost there. And the cost of electricity produced from our fuel cell is around to be 70 rupees per kWh. These are some benefits of green hydrogen. The obvious benefit is environmental benefit. By green hydrogen will definitely contribute in achieving net zero by 2070. And some other benefits like creating new industry and new job. This is a specialized kind of technology. Then there will be opening for new jobs also. The production, storage and distribution of green hydrogen, specialized expertise, infrastructure which can generate employment opportunity in all the sector of economy. Technological advancement, the production, storage and distribution of green hydrogen requires new technologies like AEM, anion exchange or SOEC. can spur the development of new material process and system, energy security and energy dependence. All the speakers have already said that our huge dependence on crude oil, and we are spending a significant amount of our forex reserve on importing the crude oil. Higher production cost. Today the cost of green hydrogen is double to the fossil fuel. So other mitigation strategies, with advancement in technology like more efficient system, we are taking 60 to 70% efficiency of water electrolyzer right now. It will go up to 90% with research and development. Then it will be a useful mitigation strategy. Using advanced material for the electrode, use of more efficient system by scaling up the production in gigawatt scale range will definitely lead the way for green hydrogen. Other one is infrastructure, or the last one is safety. The safety is the prime concern for green hydrogen. To establish the technology, we have to very much concern about the safety aspects, because the gas is very flammable, and also at higher pressure it will become more dangerous. For our pilot project, we are storing at 30 bar pressure, but like in dispenser system, or to store more hydrogen in a confined space, it will require pressure more than 200 bar. We are also taking the expertise and opinion of PESO, Petroleum Explosive Safety Organization of India, for making our plant more safe. These are some scaling of green hydrogen production bullet points. The first one is government support in the form of subsidy, incentive, tax credit, or curbing of downing the BCDs also. Developing adequate infrastructure and supply chain to enhance the production, storage, and transportation distribution of green hydrogen. Also, in need of develop skill and competency for green hydrogen production and utilization to slow down the rate of importing the material. Green energy, the need of our, the last slide, the present cost of producing green hydrogen much higher than the fossil fuel, as I already said. It is expected to come down by technological advancement. Our government mandate in National Green Hydrogen Mission is also, we have to work for this green hydrogen ecosystem to come down the cost to $1.5 to $2 per kg by 2030. The development of infrastructure for storing and distributing, storing in liquid state at 700 bar pressure is a major concern. And the last one is, there is a lot of work to do, but green hydrogen here to stay. The increase in its use will be vital in achieving climate commitments and zero emission objective that the climate emergency needs. Thank you.
Thank you. Thank you very, very much, Mr. Pradeep. I will request, please stay up here, sir. I will request Mr. Praveen Saxena also to join us up on the stage, and Mohit sir, of course, to do the honors of felicitating our speakers. So here's the team, NHDC, who presented on hydrogen-based microgrid initiatives, Mr. Praveen Saxena and Mr. Pradeep Tripathi. Thank you for coming all the way and joining us today, sir. Thank you, sir. Up ahead is the topic, which is green hydrogen application in natural gas-fired furnaces, and it will be presented by Mr. Parag from L&T. He has over 13 years of experience in L&T in different fields and has been instrumental in development of concept, FEED, EPC for green H2 and green ammonia projects, and he has led the commissioning of L&T's first GH2 project.
Play the video first. This one, fine tracks, yeah. VLC.
The quest for clean energy. The quest for clean energy has taken.
Yeah, I'll do that. Thank you. Good afternoon, everyone. At the outset, let me thank NTPC to give L&T the opportunity to present its work on the green hydrogen pilot. It's been more than a year since our green hydrogen pilot was commissioned at Hazira. And so, I mean, whatever work which was done, and so I'll be presenting a bit of that and also presenting our experience of operating that plant over the last 1 year. I'll start with a short video, about 3 minutes, and then we'll follow up with some details on the plant.
Newer heights. Larsen & Toubro, the engineering, technology and solutions company, joins industry as we rise higher. Welcome to L&T's green hydrogen plant at AM Naik Heavy Engineering Complex, Hazira. The plant, spread across 3,000 square meters, produces 99.99% pure green hydrogen and runs on advanced alkaline electrolyzers powered by rooftop solar panels. It is equipped with a battery energy storage system for storing excess power. And when the sun doesn't shine, the plant's smart energy management system, EMS, switches to BESS to support critical loads. The EMS also monitors battery health and solar efficiency. At the heart of the plant is the alkaline electrolyzer stack with anodes and cathodes separated by diaphragms and sandwiched by bipolar plates. Completing the plant's balance of systems are the electrolyte circulation system, hydrogen purification and storage systems, safety systems, substation and control center. Inside the electrolyzer stack, a 30% potassium hydroxide solution is circulated through at 90 degrees Celsius. In the stack, water is split using electricity into hydrogen and oxygen. The raw hydrogen gas containing oxygen and water vapor is purified through a deoxidizer and dryer. This hydrogen is then stored in two 20 cubic meter buffer vessels. Blended with natural gas at the pressure reducing station, hydrogen finds multiple applications. Heat treatment, welding preheat applications, and in furnaces at L&T's facilities. The byproduct, oxygen, is purified and used in manufacturing facilities. Integrated data analytics platform designed by L&T provides performance insights into the electrolyzers by monitoring efficiency, degradation, and crucial parameters. Since hydrogen is highly inflammable, robust safeguards are in place. Hydrogen buffer vessels are housed in RCC blast-proof walls. It is said that a journey of 1,000 miles begins with a single step. This is our first step. Tomorrow, we will do more. We will scale up with a PEM electrolyzer, doubling capacity and doubling carbon abatement. Simultaneously, L&T plans to boost hydrogen usage across all our facilities. Green hydrogen is an integral part of an effort to meet water and carbon neutrality targets. It will boost our sustainability quotient as we continue to rise higher.
Yeah, so that gave a brief idea of what the plant is about, and so I mean I'll just go through some more details in the slides. L&T is a big company. I mean, ranges operations and projects, high-tech manufacturing and services. We also announced our commitment towards environment in the year 2021, where we announced that we would achieve carbon neutrality by 2040. And this is taken very seriously by our senior management. It's being tracked regularly. We have interim targets and it's being tracked regularly. Also a part of that is, I mean, we identified that there's a business opportunity in the new energy business, and that's why we started carved out a business called as L&T Energy Green Tech. This is based on 3 pillars. One is on the green molecule that we will sell through development projects. The other is our strength, which we bring in through our EPC capabilities. And the third is to manufacture the electrolyzers at the Hazira plant. We already have a technology license agreement with McPhy, a French company, and we are going to start manufacturing of electrolyzers quite shortly. So this is a snippet of the news article, and this plant was inaugurated on 20th August by IOCL chairman, Mr. Prashant Vaidya, Shrikant Vaidya, sorry. And this was a good achievement. We had completed from concept to erection and commissioning of this plant in around 7 to 8 months. This is the flow scheme, and as you can see that we've installed the way we went about doing this. The flow scheme is quite simple. I mean, you split water into hydrogen and oxygen, and supply it to the applications. But what went in sizing? I mean, that's something which was new. This is an intermittent process. This has variation due to the renewable energy, and so the methodology which was followed to size this plant was quite unique and challenging, and this was being done for the first time in L&T. We estimated the demand of hydrogen based on the blending requirement and the natural gas consumption at our furnaces in Hazira. Also, we had the renewable solar profile for Hazira, and then based on that, we estimated the electrolyzer size, which was around 300 kilowatt DC, 380 kilowatt AC power. This would produce 60 nm³ per hour of peak hydrogen, and in a year would produce 15 tons per annum. The hydrogen is 99.99% pure at 30 bar. The other unique part of this is, I mean, not unique, but the nature of renewable energy. Solar is only available during the day, while our furnace operations are 24/7. So we required to size the storage, and that's what we did the storage so that the operations in the furnace could be sustained for 24 hours. We also installed a battery energy storage system, and the reason for this is that if we had to start the electrolyzer every day in the morning and stop it in the night, then we had observed that the startup and shutdown times were quite high, around 45 minutes to 1 hour from cold conditions. What we did by having this battery energy storage is to maintain them at hot standby conditions where critical operations like the KOH circulation was maintained on at a temperature of around 60-65 degrees Celsius, which enabled us to quickly ramp up the plant, start and ramp up the plant in the morning as soon as the solar energy is available in less than 10 minutes. So that's an innovation we did over here. This is just the statistics of which this. Another very critical part is where hydrogen is being used, and we did extensive collaborative testing with our burner suppliers for these furnaces to understand what is the limit of hydrogen which can be blended with the natural gas in as-is condition. And after doing that analysis, we arrived at 15% blending rate. Our piping was analyzed, and such that there is no adverse impact of hydrogen blending. After doing this, and with a lot of safety precautions like gas detectors at the point of application, we've implemented this and commissioned it successfully. Another important aspect of this is the data. I mean, we have been operating this plant for more than a year, and the data which has been generated is like gold. I mean, a lot of, and we had the foresight to put an advanced data analytics system where all this data is stored, converted into smart graphs and analytics which can be used to interpret the operations, interpret the efficiency of the operations, and where there are gaps for which can be bettered through operating procedures. We also plan to take this a step further to use the data to predict what should be the operating points in future, and thus improve the efficiency of the entire process. To sum it up, over the last 1 year, we've been able to reduce natural gas consumption by around 55 million standard cubic meters. Also, we reduced our grid power import because of the excess solar which was generated, maybe around 10 to 15 million units. And also in the process, we've reduced our carbon footprint by around 300 tons. This just proves that this is not only making climate sense, but has a lot of business sense also. And I think so more such forums where we can present and we listen to ideas from my various other the presenters gives us a lot of ideas to implement green hydrogen in the future. Thank you.
Thank you so much, Mr. Parag. Thank you so much for sharing the L&D perspective. Kindly stay up here, and I request Mohit sir to felicitate Mr. Parag with a token of appreciation. So thank you to you and to the team from L&T. Green hydrogen using off-grid solar. So what is that? Country's first of its kind off-grid solar photovoltaic-based green hydrogen pilot project is in Ujjain, Madhya Pradesh, and it aims to establish independence from grid power. I invite the team from Hygenco, Mr. Anshul from Hygenco, to share his perspective on the topic, please. Mr. Anshul Gupta has an experience of over a decade, and Hygenco deals with EPC and BOOT expertise in green hydrogen and green ammonia field.
You want to play the video first or this? I'll do the PPT in between, I'll switch.
Okay, thank you. Good afternoon, everybody. My name is Anshul. I'm from Hygenco. Just a very quick overview of what is Hygenco. Hygenco is a dedicated green hydrogen company which was set up in early 2020. And it is supported by NEEF fund, which is actually a multilateral capital fund from around 4 different countries. Our mission is basically to support the green hydrogen economy in India. And what we do is we develop green hydrogen assets across the country on a build, own, operate basis. So it's, I think, currently, we have around 65 to 70 dedicated green hydrogen team, which may be one of the largest green hydrogen teams in India today, with very deep expertise around energy systems as well as industrial gases, industrial safety, process safety, and the hazardous operations. In March last year, we commissioned a pilot project in the heartland state of Madhya Pradesh, somewhere near Ujjain. This is just a brief photo of that project. It was 100% green hydrogen. By 100%, I mean that it is actually off-grid. It is not even connected to grid. There is no chance of any thermal power flowing into this hydrogen plant. So this hydrogen plant, if you can see in the photo on the left side, there is around a 80 megawatt solar farm, from which a piece of the solar farm was cut. made off-grid and fed it into the hydrogen plant. And it is very closely located to around a 200 megawatt wind farm. So we have the ability to draw also and test it from wind power as well on off-grid mode. This plant has been now been operating since almost 30th or 31st March last year. So almost reaching around 17 months of operation. And this plant is a fully autonomous green hydrogen pilot plant powered by off-grid solar. And let me just explain what I mean by autonomous. There is automation and there is autonomous. What we have done over the time, we have made this plant like a Tesla. So we have put so much intelligence into the plant. It is continuously connected to the cloud. It is continuously interacting with the satellites, continuously monitoring what is going to happen in the future, and automatically predicting and setting its own data points. So the plant is thinking on its own. The autonomousness has gone to so much level now that we don't need operators in the plant. There is only one operator in the plant who is also the security guard. The plant just operates automatically. It just wakes up every morning, watches what is going to happen, watches the sky, watches what is going to happen in next few hours, maybe cloud covers are going to come or not going to come, etc., and continuously makes predictions and optimizes itself to produce the lowest cost of hydrogen. So this is a major innovation that Hygenco has done to make the plant autonomous in nature. And this gives us confidence that now we can scale up to any scale because the autonomous decision making of the plants make the hydrogen cheaper. This plant, of course, is 100% geographical correlation, and it is 100% temporal correlation in real time. And by real time, I mean less than 100 milliseconds. So in Europe, we have this concept of temporal correlation these days and geographic correlation, which Europe is trying to come up with. On hourly temporal correlation, we achieved milliseconds, 100 millisecond level temporal correlation here, which is far better than what Europe has done so far. So our definition of green hydrogen is the greenest of the greenest in the entire world. I'll just show a quick video. There's some issue with the sound.
No, volume is not there.
Maybe open a different player.
Let me try. You can simply narrate.
Yeah, I'll just narrate. I think it's some technical issue, I think the audio not being played. So this is the location where there is almost an 80 megawatt solar farm commissioned back in 2013. And here is where we have put near Ujjain. It's our green hydrogen pilot plant.
Situated in India's central heartland state of Madhya Pradesh, we have set up first such green hydrogen generation plant. This plant is 100% powered by renewable power and supported by advanced battery storage technology. Hygenco plant is fully automated using advanced energy management and control system. This system monitors the incoming renewable power and dynamically decides between energy storage, hydrogen generation and hydrogen storage. These plants also use the latest technologies in forecasting renewable power, cloud and edge layer computing and AI-driven operations to provide the lowest cost of green hydrogen. Innovation in design of plant allows us to easy scale up to large size production units and any industrial usage. We are fully committed to safe industrial gases operations. Hygenco's industrial quality management system ensures safety procedures and SOPs are adhered to during the plant construction, commissioning and regular operations. At Hygenco, we are taking giant leaps to bring a true energy revolution driven completely by renewable energy. We are ready to bring the green hydrogen revolution in India.
Yeah, as I said, this plant is entirely off-grid, and it naturally knows through forecasting at what time exactly to wake up in the morning. Through its temperature and pressure controls, it uses AI to continuously forecast and predict, based on the cold startup time and hot startup times, when is the time to actually wake up in the morning. So nobody needs to tell this plant anything. It just optimizes the cost of hydrogen automatically at every point of time, within every few minutes. So with this success and a lot of operating data through which we were able to put machine learning into the process, we basically went ahead in scaling this up. So the same concept. So in around August last year, we signed India's first long-term offtake agreement. It's a 20-year fixed price offtake agreement of green hydrogen. And in this case, we managed to achieve a price cheaper than gray hydrogen. This project also became the first green hydrogen project in India to achieve FID and to be financed by commercial banks. The project is about to be commissioned in November. It is almost in advanced final stages of construction by now. We also signed another long-term offtake agreement in India in around June 2023. So we scaled up the concept even further. Now that we had the success with solar, we now went ahead and signed a 20-year offtake agreement in India based on solar and wind. The same concept now scaling up, having two sources of RE power, further reducing the cost of hydrogen. And it was, again, in this case, we managed to achieve the cost of green hydrogen cheaper than the gray hydrogen. This plant is also under construction. Currently, we are developing close to 300 megawatts of wind and solar capacity in the country for our green hydrogen plants. So the pilot has now scaled up. So just the plant that is just under construction right now, very identical to what we had at the demonstration plant or the pilot plant in Ujjain, is basically a commercial plant with a 20-year offtake on exactly the same concept. However, it is also a floating solar-based plant. So the RE power is being generated from floating solar and rooftop-based solar. It saves evaporation. It is 100% off-grid. It does not touch the grid anyway. No thermal power can ever flow into this plant. And it has major innovations in the solar plant electrical design, where a lot of non-conventional equipments have been used that has never been used in the solar industry before in India. Like some very special string optimizers, DC-DC converters. The entire electrolyzer is not even connected to a rectifier. It is directly fed through DC power. So achieving much higher efficiencies. So while I think the presentation I had was on the off-grid solar and using microgrids, there are some strange regulatory questions around it. When you create a microgrid-based, let's say, or an off-grid hydrogen plant, all the questions come around the regulations around the RPOs and RECs. A bit strange thing to have, but so some of the regulations say that all the power that is consumed by such plants, because it's above their own RPO, because they don't have any RPO, is directly attributed to the DISCOMs. So that makes these plants by law non-green. Although they made green hydrogen, the green attributes were taken by DISCOM just by law. But the funny thing is that the DISCOMs cannot meter it because there is no framework for the DISCOMs to meter off-grid plants. So DISCOMs cannot also count that green attribute. So in the end, nobody ends up using the green attribute. Neither the DISCOMs are using, neither the developers can use, nor the customers can use. So I think there are some gaps in the regulations that need to be fixed in order to scale up such kind of concepts, and it's simply a regulatory gap. So at Hygenco, what we do, we basically design the entire renewable to green hydrogen plant through our own softwares developed in-house, which optimize the end-to-end capacity. We do the entire basic engineering prime EPC in-house. We have a full global chain of supply chain of electrolyzers. There is almost no electrolyzer vendor in the world that doesn't work with us by now. And we have our own proprietary digital twins-based platform, which continuously optimizes and decides what to do in real time without any human intervention. So that's all. Thank you.
Thank you so much, Anshulji. Thank you so much. We totally understand that there's so much that you have to share and so much that we have to learn from you. Would you please kindly stay up here? So thank you for your perspective, and I'm sure that the discussions will be carried forward during the lunch break of the seminar conversations. I now request Mr. A. Balan, Member Planning CEA, to do the honor of felicitating our speaker. Thank you so much, Anshulji, for sparing time out for us and for sharing your perspective. Much appreciated. Thank you so much, Balan sir. Well, just two discussions away from the much-awaited lunch break, but I know you've been very kind to us. You've stayed put, you have supported. Thank you very much for being here throughout and for your rapt attention. I now invite Ms. Ritika Gaur, who's the Head of Marketing from So High-Tech. So High-Tech is a startup collaboration with Swiss Federal Institute of Technology based out of Lausanne, Switzerland. And So High-Tech has, yes ma'am. So High-Tech has developed an innovative photoelectrochemical technology for green hydrogen production directly from solar energy, promising high efficiency.
This one. This one. Yeah, you can do that.
Very good afternoon, everyone. My name is Ritika Gaur. I am the project marketing head of company So High-Tech. About So High-Tech, we hold world record in terms of producing green hydrogen from solar power. We come with a research and development of 10 plus years and of course, a combined experience of 100 plus years of the co-creators of this technology. It's a spin of EPFL, which comes among the top 10 universities of the world. We are based out of in Switzerland, Lausanne. Going further, as since morning, we have been talking about hydrogen, and we know that by burning of fossil fuels has been creating a lot of environmental hazards. Now, after deeply visualizing and analyzing the market, we got to know that the fuel of the future is hydrogen. Being hydrogen, one of the cleanest fuel, and of course being used by various industries. Going further to it, in one of our statistic report, we analyzed that 96% of the hydrogen is being produced by burning fossil fuels. Now, about the rest, by electrolysis method. But why only 4% have been using the method of electrolysis? Because we conclude that, the transportation cost and the other operation costs take a bit higher in terms of costing. Going further to it, what So High-Tech is bringing up in the market? So High-Tech has come up in the market with a product called ARC. In Latin, it is known as a tree. Now, what is it? What does it do? Basically, it's an artificial tree which just works like a living tree. Now, it takes two renewable resources like sunlight and water and produce back hydrogen, electricity, heat, and oxygen at the same time. Going further to it, I just wanted to tell you it is one of the groundbreaking inventions so far. Moving further, let's just go a bit in detailing about the ARP. It saves up to 80 tons of carbon dioxide per year. Basically, it is very, very high in terms of efficiency and very low in terms of costing. It is a cogeneration system because it is not just giving you hydrogen at the same time, but giving you oxygen, heat, electricity on the other hand. Now here, I wanted to tell you that what exactly the technology behind it. It is integrated photoelectrochemical device, how it has been implementing. So in a rough way, I just wanted to explain you. So basically, the sun rays is falling on the concentrator. From the concentrator, it is reflecting back to the reactor. In the reactor, the whole process of photoelectrochemical has been taking place. Now, the basic science behind it, what we are exactly doing it. So the sun rays, we are converting the sun rays into electrical charges, and through electrical charges, we are splitting the water into two parts, that is hydrogen and oxygen, and further storing it. As I wanted to show one small video over here. So I think, because the video is not working probably, I think probably, sir, we can do it. So you can see the arm has been rotating as per the directions of the sunlight. This gives the system 80% more efficiency. It's a plug-and-play technology. It is, very, very low in terms of costing and occupies a very less of land. Going further in the presentation, we wanted to tell you over here, it is one of the patent technologies, 24-hour constant fuel production at 100% capacity of sun plus grid. Now, how the business we are scaling up? We are coming up with an ARP forest and ARP garden. So 50 plus of ours is known as ARP garden. 100 plus of ours is known as considered to be an ARP forest. We are already operational in this project. We will be completing soon this project in Lausanne, Switzerland by 2023 December itself. Going a bit more detailing into the ARP. So basically, if you see, there is a So High-Tech container. So this one single container manages and operates all the ARPs present in this particular forest. It is twice more in terms of efficiency, twice less in terms of costing, and of course, twice less in terms of space taking. Now talking about the product readiness. So we would like to tell you over here, the product is almost mature and ready as per photovoltaic and PEM electrolysis. It has reached the level of 8.5 as per the readiness. Diversified portfolios, we are present in the market with 3 different meters of ARP, 9 meters, 13 and 25. The 9 meters gives you, it's produced 10 kg of hydrogen in a day, 13, 20, 25, 80 kg per day. Moving further to our business module, we develop, build, and operate. Basically, we do have our local partners present across the globe, and we are working with them. Talking about the product positioning, we wanted to compare here our product with steel forming method, I'm sorry for the word, using wrong word, and electrolysis method. So according to them, the sustainability of IPEC technology, which is our technology, is very high and the pricing is very low. So we are almost about to reach $2 per kg of hydrogen. So here is a small video for you to see one of our pilot projects which is already running in Lausanne, Switzerland. So as I said it in my first slide, we hold the world record, and here is the love and support which we have got across the globe. Talking about us, our company is based out of in Switzerland. The main research and development team sits over there, and we do have an operational office in Delhi, India itself, in Aerocity. Going further, here is a glimpse of our team, who is the basic code creators of this technology. And I end up my presentation over here by saying, by mimicking the nature, our vision is to create technologies for solving current energy dependency. Thank you.
Thank you very much, Ritika ji. That was very crisp and very to the point. Thank you very much. Please stay up here. I request Shri Rajput, Shri A.K. Rajput ji, Member Power Systems from the CEA, to kindly do the honor of felicitating Ms. Ritika Gaur for her contribution and the contribution of her company in the seminar today. Thank you so much, Rajput sir. Thank you. This is much, much appreciated. So we have been listening to a lot of speakers since morning. There have been a lot of discussions, and we have last one in the series up next. The team from Indian Oil, Mr. Sachin Chugh, Deputy General Manager and also the STA to Director R&D is here. He'll be sharing the perspective of his organization on hydrogen initiatives in the Indian Oil.
So good afternoon to all of you, and thank you to Mohit sir, for entertaining my request of presenting, although we were a little late in agreeing to present. And I'm sorry also for standing between you and lunch, but I'm sure, going to finish in another 5 to 7 minutes. So the journey of hydrogen at Indian Oil, and we have been witnessing for the past 18 years. The profits of the so-called clean energy or the green energy were not that enthusiastic about 18 years back when we began our steps in hydrogen at Indian Oil. And we have been taking it through various pilots, through various R&D activities, and I'm happy to see so many stakeholders with whom we have been working together are present in this room. We collectively saw the dream of taking it forward, and here are we, where India is at a standpoint where we as a country and a nation are projecting ourselves to take forward the giant leap in the field of green hydrogen. We started our journey in 2005 when we commissioned India's first hydrogen dispensing station. The idea at that time was not to move into the space of electric vehicles, but how to reduce the pollution coming out from the CNG vehicles at that time. And hydrogen seemed to be the alternative, and we started our journey with HCNG blending. Series of experiments took place, and we were joined hands with the various automotive OEMs. Most of them are present here in this room. And we began our first tryst with hydrogen economy at that time. HCNG at that time was being conceived as much cleaner fuel, and this is what we proved in the recently concluded experiment on 50 transport buses of DTC in Delhi. This experiment was a result of the highest court taking into cognizance the efficacy and the advantages of HCNG, and we could reduce the pollution, especially in terms of CO and HC, by more than 70%. Now, this is the story of the usage of hydrogen in the IC engine, which we restricted at that time to 18%, primarily because we didn't want any kind of modifications in the IC engine platform, and we wanted to use the existing CNG engines for that. And Coming on to green hydrogen, we have recently commissioned a station based on green hydrogen at IOC R&D, and this station is going to soon fuel 15 fuel cell buses, which we are going to run in the city of Delhi. And these green hydrogen platforms, we are exploring multiple aspects of it, not restricting ourselves to only the electrolyzer-based hydrogen, which we do feel that it is going to be one of the favorite aspects or one of the favorite pathways as far as India is concerned. But we are also going ahead with biomass gasification, particularly strengthening our partnership with the Indian Institute of Science, Bangalore, for taking forward the oxy-steam biomass gasification technology. With so much of policy happening around compressed biogas, we feel that that can be one of the potential low-hanging fruits as far as green hydrogen is concerned. And so we are also setting up one of the pilot plants of 10 kg per hour green hydrogen capacity based on CBG reforming. And parallelly, we are working on various kind of electrolyzer technologies, be it the AEM or the PEM or the solid oxide cell. We believe that all these technologies are going to have their niche markets available as the time goes by, because once we are targeting the application, be it the mobility application, so we will have a different kind of electrolyzer being suitable for that application, or the high-end heat applications, particularly in the refinery, where we feel that the solid oxide technology is going to make much more sense. So going forward, you are going to see a fleet of fuel cell buses operating on green hydrogen in Delhi NCR pretty soon. We commissioned first commercial hydrogen dispensing station at our Gujarat refinery. Incidentally, this station is operating on natural gas at this point of time, but yes, we are taking steps to convert again, operate it on CBG. And the 2 hydrogen fuel cell buses we have been running through this station along with our partner Tata Motors, and we have generated significant data in terms of performance and durability as far as fuel cell operation is concerned. We have been at IOC R&D, we have understood the importance of hydrogen storage, and the importance of indigenizing the technologies, and therefore we are working very closely with the IIT Kharagpur for developing our indigenous type 3 tanks, and so with a storage pressure of 350 bar, and we believe that a strong cost competitive advantage is going to be there when we are going to have these tanks produced indigenously. On the fuel cell side, although many believe that the low temperature PEM fuel cell is going to be, it's very sensitive to the hydrogen impurities, and coming from the fuel supplier background, we took up this challenge of undertaking the R&D experiments on planning and understanding the impact of impure hydrogen on low temperature PEM fuel cell. And recently we have filed a patent, where we have been able to overcome this challenge of operating the PEM fuel cell on 100 ppm of CO. And this particular technology is going to open up multiple pathways, primarily targeting the reduction of cost of green hydrogen, especially when it is produced from biomass or CBG reforming. We last year we actually developed one fuel cell e-bike, and the idea is that in a environment where shared mobility is going to be the call for the day, we want to explore the advantages of hydrogen, particularly taking forward its own advantages of longer range in terms of per fill, and we want to explore this shared mobility on e-bikes and take it forward from to be refueled from the IOC retail outlets. Recently, we have come across the setting up of 10 KTA of green hydrogen plant in Panipat refinery, and this is going to be one of the biggest electrolyzer setups in the refineries as per now. And this is going to create a lot of interest and buzz in the market, and I'm sure that many stakeholders who are present in this forum would be interested to take forward and participate in this opportunity. We also, Indian Oil has formed one joint venture company with L&T and Renew, the GH4 for India Private Limited, and this company is going to take forward all the aspects of the green hydrogen supply side as far as IOC is concerned and the external market is concerned. We have been refueling and extending our refueling facilities to various OEMs. Toyota Mirai is being shown on the bottom right-hand side of the slide. And however, we are in discussions with different OEMs to enable them introduce the hydrogen fuel cell vehicles in India. So in a nutshell, as I conclude my talk, this has been a fascinating time where at IOCL we have been encouraging and promoting the use of hydrogen, and I think that this is the moment where all the stakeholders should come together and join hands in order to usher in hydrogen economy for the country. Thank you very much.
Thank you so much, Sachinji. I request CEO NG EL to kindly felicitate Mr. Sachin from Indian Oil for sharing his perspective and for being a part of this seminar. Thank you so much. And now that we have Mohit sir right here, he's been so instrumental in threading this entire seminar at such a short notice. And he has been not just managed to organize this, but to have all of us threaded together in this. So thank you very much, sir. We can't do without your closing remarks.
So actually, you don't want people to start getting lunch. So quickly, first and foremost, thanks all of you for actually coming here at such a short notice. We are really, really obliged. We couldn't have done it without you. So this is phenomenal, and I'm really quite excited to have seen some of the presentations. Honestly, I missed a few, but whatever I saw was very good. Just one quick word, hydrogen and power sector. So like we are power sector people. So for us, hydrogen has been there since the very beginning. So when people get very excited about hydrogen, we are still kind of perplexed. We don't know why it's so exciting. Because when we set up our first power station in Singrauli in 1982, there was hydrogen. So we had an electrolyzer. We were producing hydrogen. So for us, hydrogen has been there all along. But now it's a renaissance happening with hydrogen, with green and blue and so on and so forth. So as we heard the Honorable Minister in the morning, this is the time to seize the moment. This is a time for India, and this is time for lunch. So I think once again, thanks a lot. So please join us for lunch.